περισσότερο.
Η Λάνα είναι πρώτη.
Και ο Βασίλης.
Where is Nada? Guys, Nada, where is...
Δεν ξέρω, ξεκινήσουμε χωρίς αυτό.
Nada means nothing in Spanish, so when you say find nada means find nothing.
Εύη, θα είναι κανείς από το σχολείο εδώ να πει κάτι? Τώρα ή μετά? Ίσως μετά, θα μου πεις, να ξέρω τώρα και άμα είναι... Πώς είπαμε την Ινδική Μαργαρίτη. Η Μαργαρίτη... Απλά να μου πεις να σου...
Μπράβο που αγοράζει όλα τα ευρώ. Όσο ώρα που πέφτει για το price ladder της Apple. Πόσο pretentious το θες να σου λέει. Πόσο performative. Ρε βαριέμαι τώρα, βαριέμαι. Έχω σπίτι μου.
Εγώ ξέρω τι βαριέμαι,
Τι ώρα φεύγεις?
και μόλις γυρίσω, θα πάω τα παστερία.
Superposition.
Ναι, ναι.
1, 2, 3, 4. Ξέρω να μετράω και μέχρι το 10.
Καλημέρα σας. Καλώς ήρθατε στον μεγάλο τελικό του 7ου YNL.
Good morning. Welcome to the 7th finals of YNL.
Ντοντό, νομίζω ήταν ένα πολύ ενδιαφέρον διήμερο. Οι ομάδες ήταν πολύ ανταγωνιστικές. Είχαμε ανατροπές στο τέλος. Πώς το είδες?
Ήταν όντως ένα πολύ ενδιαφέρον τριήμερο. Είδαμε πολύ ενδιαφέρουσες λύσεις. Είδαμε παιδιά από όλη την Ελλάδα να διαγωνίζονται. Και ήταν πολύ ενδιαφέρον να δούμε και τις ομάδες να δουλεύουν μαζί.
Όμως κάποιοι τα κατάφεραν και βρίσκονται σήμερα μαζί μας 3 ομάδες για να διεκδικήσουν τον τίτλο του απόλυτου νικητή.
So, but 3 of the teams that were participating made it to the finals, and they're here to win the tournament.
Τι έχει γίνει μέχρι στιγμής? Όλες οι ομάδες, 29 ομάδες που βρέθηκαν εδώ προχθές, έπαιξαν σε 3 science fights. Από αυτές, οι 9 καλύτερες χθες το απόγευμα προκρίθηκαν στους ημιτελικούς. Όταν τελείωσαν οι ημιτελικοί, οι 3 νικητές προκρίθηκαν στο μεγάλο τελικό και είναι εδώ μαζί μας σήμερα.
The first day of the tournament, we had all the teams competing, and the second as well. After this phase finished, we had the 9 teams passing on the semifinals, and from these 9 teams, we had the 3 finalists that came from each room of the 3 science fights that came out, and here we are.
Ποια θα είναι η διαδικασία σήμερα?
The procedure today will be:
οι ομάδες έχουν ήδη επιλέξει το πρόβλημα που θα παρουσιάσουν στον τελικό.
the 3 teams have already chosen the problem they will present to the finals.
Η κριτική επιτροπή αποτελείται από τουλάχιστον 10 άτομα.
The jury is made out of at least 10 people.
Θα παιχτούν 3 stages όπως προβλέπεται από τους κανονισμούς.
3 stages will be held today as the rules say.
Το σημαντικό και διαφορετικό εδώ είναι ότι δεν μετράνε τα σκορ από τους προηγούμενους αγώνες, άρα αυτός που θα κερδίσει το σημερινό αγώνα είναι ο απόλυτος νικητής.
The important thing here is that scores from previous science fights do not matter, so the winner of the tournament will be the winner of today's fight.
Για την επιλογή των ρόλων θα διεξαχθεί CupExS contest.
For the choice of the order of the sequence of who's going to play first, second, and third, CupExS contest will be held.
Έχουμε μαζί μας λοιπόν στην Κριτική Επιτροπή ως chairperson τον κύριο Μλαντέν Μάτεφ. Mr. Mladen.
What did you want? Okay, welcome everybody here. I hope that we are going to have a very interesting fight. Everybody looking forward to learning something new from the problems that were going to be presented. Good luck to all the teams. Good luck to all of the people showing up on stage. And let's have an interesting tournament final. Thank you.
Ο κύριος Φίλιππος Καλούδης.
Good morning, everyone. First of all, congrats to the finalists. Great job to be here, and I wish everyone the best of luck. Enjoy the fight first and foremost, and yeah, I'm glad to be here. Looking forward to seeing your solutions and seeing the fight. Thank you. Good luck.
Miss Nada Matas.
Ευχαριστώ, and thank you for doing this amazing event. You've all done really, really well. And it's a pleasure to see the next generation devoted to something so big. I wish you really to succeed in this competition, and don't feel sorry if you don't win, because there is a bit of a statistics in all this. So don't feel too proud if you win. Don't be too sad. If you're doing it next week, the week after, the statistics might bring a different results. So you're all winners. You are 3 of 30 teams. So good luck, and you're doing the great job. Thank you.
Miss Fedra Miss Mirtota Ripsiado, sorry.
Thank you for this. Okay. Hey guys, congratulations everyone. Okay, let's stand up. Congratulations everyone. I'm so excited to see your performances. You have done a great job so far. So yeah, have a great fight, have fun, and yeah, congratulations again.
Mr. Alexandros Kaimakis.
Okay. Hello, I'm Alexandros Kaimakis, and it's a pleasure to be here. This was a very interesting competition. So we saw very interesting solutions. Congratulations again to all of the teams, and may the best team win.
Mr. Dimitris Apostolidis.
Okay, hello everyone. Congratulations to all the teams that have made it to the finals, and may the best team win. Thank you.
Miss Fedra Tsolakidi.
Good morning, everyone. It's a very big accomplishment to be here out of 30 groups, so everyone is a winner, and don't forget to have fun.
Mr. John Kalangis.
Hello, everyone. I hope you had a great tournament this far. I hope you enjoy the final fight as well, and may the best team win.
Miss Konstantina Petrogianni.
Hello, everyone. Have a nice fight and have fun.
Mr. Zisis Diamantopoulos.
Hello, everyone. Good morning. I'm gonna wish you good luck, and let's have a great fight.
Mr. Thanasis Pantazopoulos.
Good morning, everyone. Congratulations, first of all, to all the teams that took part in the tournament. Congratulations to you guys for making it to the finals. Good luck. Let's have a great fight and enjoy it.
Ms. Zacharula Kigmiki.
Hello, everyone. Congratulations. Best of luck, and don't forget to enjoy it.
Ms. Victoria Miridou.
Hello to everyone. Good luck, and may the best team win.
All right. Okay. Thank you very much for being here and helping us with the jury. Now, Dodo, we have our finalists. So, we have with us Team Revolutionaries. Captain, say a few words. Captain, say a few words. And present your team.
Okay. We are Team Revolutionaries. This is Christina, Faye, Elena, Katerina, and I'm Ioanna. We are very excited to be here, and we wish you all good luck.
Team Lab Legends.
Well, we're Team Lab Legends. This is Danai, John, Konstantinos, Dioni, Kiveli, and I'm Michaela. I hope everybody has fun. Congratulations to all the teams, both here and the ones who didn't make it to the finals. And may the best team win.
And Team Absolute Zero.
Good morning. We're Team Absolute Zero. I'm Anastas, he's Vasilis, Joseph, Vasilis again, Ileana and George. And we wish good luck to everyone.
Good luck. So, Mr. Matev, we're going to start now.
Now we're ready to proceed to the captain's contest. For everyone in the crowd that doesn't already know what captain's contest is, the teams will be presented with some questions and they will have to answer. The team that gets the most correct answers will be the team that will decide the order of the stages, who's reporting, opposing, and reviewing first.
Okay, the captain's contest is being taken care of the jury part that's in charge. We are going to have 5 minutes for the team captains to decide on the best answers. So make sure that you concentrate, you work without any interaction with anyone else outside. How are they going to be seated? Okay, you need to prepare a 5-minute timer, which is the discussion timer, I believe. Yeah. Discussion timer has 5 minutes, yeah. Excellent, yeah.
Okay, I need the 3 captains. I will not make it easy. I will not make it easy for you. Come on the stage. The 3 captains. Take a pen, take a pen. Go to the stage. Okay, come on the stage.
Yeah, you need to be seated separately.
You will not be seated, you will be... Ανεβείτε πάνω, όρθιοι. Όχι, όχι. Εδώ ένας και ένας. Εδώ μπροστά. Ένας και ένας. Μακριά ο ένας από τον άλλο. Οκ. Αλέξανδρε, διάβασε τις ερωτήσεις πρώτα. Τις έχεις? Okay, please read the questions.
Give them face down
Start.
Okay, we are
the microphone to Mr.
Starting the timer. Okay, the text of the questions will be read out first, and then we'll have the timer started.
Okay.
No communication further on.
Okay.
Go ahead, please.
Okay. So the first question is, what is another name for the TCA cycle? What is another name for the TCA cycle? The second question is, which number corresponds to the number 1110 in binary form? The third question is, which particle has the same mass and spin but opposite charge from the electron? The fourth question is, how many chromosomes does the chairperson have? And the fifth question is, are the atomic orbitals of the same shell for a multi-electron atom degenerate? Thank you very much.
Shall we start the timer? Let's start the timer, and you have 5 minutes. Quiet in the room, please. They are working.
Ωραία. Τα παιδιά έχουν τώρα 5 λεπτά να απαντήσουν στις ερωτήσεις που έκανε ο κύριος Καϊμάκης, με σκοπό να δούμε ο νικητής να διαλέξει τη σειρά των ρόλων. Χωρίς να τους αγχώνουμε καθόλου. 3 more minutes. It's hard to be a captain.
You're the fastest.
As you understand, a good captain for a team is not only a person with very good organizational skills and science knowledge, but also a wide and profound interest in natural sciences, so that they would be able to answer a diverse set of questions.
Okay, everyone is ready. Yes, write your name on top, or your team name. Your team name. Since they finished.
Are they finished? Oh,
Yes.
right.
Give it to me.
Very nice.
Thank you.
Well,
Thank you.
there is still 1 more minute, and they are already finished. So we can stop the timer now and have the jury grade the questions.
No, wait, because the winner will decide the sequence of the roles. So
Let's have that.
think about it. Ουσιαστικά ο νικητής αυτού του μικρού τεστ θα καθορίσει τη σειρά με τον οποίο θα παίξουν τους ρόλους στο πρώτο stage. Όπως γνωρίζετε, ο αγώνας αποτελείται από 3 stages. Η κάθε ομάδα παίρνει τον ρόλο του reporter, του opponent και του reviewer κυκλικά.
Okay, the committee on the captain's contest is ready to announce the result.
Okay, so the results from captain's contest were Absolute Zero were granted 2 points. Lab Legends were granted 4 points, and the Team Revolutionaries were granted 1 point.
Okay, congrats.
So the winner, yes. So the winner of the captain's contest is Lab Legends. Okay, congratulations.
Μιχαέλα, θα πρέπει να διαλέξεις τώρα τη σειρά των ρόλων για το πρώτο stage και τα υπόλοιπα θα πάνε κυκλικά όπως προκύπτει από τον διαγωνισμό.
Mihaela, now you have to decide the role of the roles, which will be first, second, and third as reporter, opponent, and the reviewer, and the process is circular. So reviewer does a position in the next stage, opponent does reporter in the next stage, and reporter is a reviewer in the last stage.
Okay, so for this first stage, we want the reporting team to be Absolute Zero, the opposing team Lab Legend, and reviewing team Revolutionaries.
Nice.
Thank you very much. Now we have clear sequence in which the teams will appear on stage.
Okay, so let's start the clock for the preparation time.
Yes, we can start the preparation time for the first reporter, And let's keep it quiet in the room. Whenever I announce the preparation time, we want to keep the noise level down in the room so that they can prepare and concentrate.
Ντοντό, οι αγώνες ξεκινάνε. Έχεις περιέργεια να δεις ποιος θα κερδίσει?
Πολύ περίεργη, γιατί βλέπω 3 ομάδες μπροστά μου που είναι και οι 3 πολύ δυνατές.
Και είναι και οι 3 ομάδες που έχουν ξαναπάρει μέρος, έχουν εμπειρία από το διαγωνισμό. Άρα δεν είναι κάποια ομάδα που δεν το έχει ξανακάνει αυτό, δεν το έχει διαχειριστεί.
Ναι, αυτό είναι όντως η πραγματικότητα. Και τις 2 ομάδες, τους Lab Legends και τους Revolutionaries, ήταν και οι 2 στο τελικό του ελληνικού πέρσι, νομίζω κιόλας.
Ωραία, ας αφήσουμε τα παιδιά να προετοιμαστούν. Καλή επιτυχία σε όλους. Mr. Matev, you are the chairperson, so you are in charge now. Thank you very much.
So you can prepare for the beginning of the report, and then I'll announce the beginning of the report. I have some usual remarks at the beginning, which I'll use to remind all the people appearing on stage to speak loudly and clearly and understandably, so that everybody can see and understand what is being said. Also, please stand in such a way so that you don't stand in the way of other people looking at the screen. Make sure that all of the people present and participating in the tournament can see the clock. Make sure that everything that on the waist when you run to the stage, you don't have any cables that you can trip over. And if there are any other technicalities, please let us know or address some of the technical personnel around here. And let's have an interesting and exciting fight. That's the captain's contest. Oh, is that the preparation time? Okay, that's fine then. Make sure that you prepare well, but if you don't need to use all of your timer, all of your preparation time, let us know so that we can proceed further with the report. Yes? Yeah, should be 3 minutes. It's only 3 minutes of preparation time, normally.
I know, because this take a lot of sense of my court for some reason.
Okay, yeah, we need to get the correct one. Yeah. But if you cannot find that one, that's possible. Yeah. Everything was okay. They are having their preparation time. Where do you want? What did you say? Yeah, the speaker will be standing somewhere here so that there will be a possibility for team members to run and deliver written notices. And the discussion will be taking place here, so make sure that you don't trip over cables. Oh. I don't have any extra slides to give you. got a problem with their slides. Oh, that's what it is. Yeah, okay. Yeah. Maybe work with the response. But that's okay. All right. All right. Looks like we're all set. Let's make sure that the timer is ready for the beginning of the report. Feel free to let us know when you're ready to start. And I will announce the beginning. Don't start the timer until I say so. Reporter, are you... We're waiting for a signal from the jury member to be able to start. John, is everything fine? Is everything okay? All right, so we are ready to start, I'm assuming. Let's have the reporter confirm that you're ready to, that he's ready to start. Yeah. All right, you have 8 minutes, starting now.
Hello, my name is Vasilis Nikiforidis, and today we'll be presenting problem number 6, wrinkly fingers, which suggests that fingers or toes, when soaked in water, are wrinkled. We should perform experiments to validate or invalidate possible mechanisms for this effect, and after that we collect data to show how properties of different wrinkly fingers and toes depend on the relevant parameters. Also, here we can see that the skin wrinkling, which is also known as water-induced wrinkling, only happens on hairless skin. Can move on. And the problem statement suggests that we should validate or invalidate various mechanisms. And we study the passive hypothesis, which happens with osmosis, and the active mechanism with vasoconstriction. Move on. So the passive hypothesis states that the outer layer of the skin, which is the stratum corneum, contains dead keratinized cells, which contain a high concentration of salts, such as salts and proteins. And osmosis works like when the water molecules move through the semi-permeable membrane of the skin from a high to low concentration solution. When placed in water, the water will flow into the cells. And that will make the cells swell and increase in surface area. Thus, this change in surface area will make the skin to buckle and form these distinct wrinkly patterns along the surface of the skin. Come on. So if the passive mechanism is true, the temperature should have a minor effect in wrinkling, depending on different temperatures each time, and tonicity would have also an effect on the experiment, as high salt concentration should prevent wrinkling, and low salt concentration should swell the cells as water flows into them. That is when the phenomenon is visible. You can move on. Here's the active theory where water enters the sweat ducts, and they alter the electron balance in the pores. This signals the sympathetic nerve fibers, and thus this trigger the vasoconstriction mechanism by the nervous system. Thus the volume of the finger is lost and the pulp is reduced. And then the outer skin reduces in volume, and thus the skin buckles into those distinct wrinkly patterns, as we said earlier on. Move on. So if that's true, tonicity will also play a part in the experiment, as wrinkling will still occur as nerves still detect the water, however the process will be slowed down. Also, nerve health would play a part in the experiment, as this mechanism is an active response of the nervous system. And the temperature of the water the hand is sunk in will also play a part in the experiment, as the higher the water temperature, the larger will the wrinkling be along the surface of the fingers. And here are hypotheses. The first one has to do with the first part of the problem statement, which suggests that we should evaluate and study this mechanism. So we hypothesize that the wrinkling will occur much more in the case of temperature change, supporting the active theory. And the second part, where we were assigned to test to invalidate or invalidate possible mechanism for its effect, we studied that the wrinkling will most likely stay the same if we have a margin of 25,000 pixels or less difference from the initial value. In the case of tonicity changes, disproving the magnitude of the effect of the osmosis theory. So our independent parameters were the salt concentration and the water temperature. In the first experiment, we tested 22, 32, and 14 degrees Celsius, and we tested the finger wrinkling. It's not in percentage, it's pixels total. And here are control parameters. You can move on. Here are experimental apparatus. We use the same finger for each experiment, which we tested under the same distance from the camera. A volumetric container with a solution, the distilled water, some salt for the second experiment, a controlled water bath to maintain the temperature constant, to minimize errors, a thermometer, a camera to take photos, imaging for analysis, and a scale. Here is our experimental plan, and you can move on. First of all, we place the finger flat on a wet paper towel. We photograph the dry finger directly from a steady distance that we kept constant for the rest of the experiments, and we ensure uniform lighting to minimize errors. We also said that this image serves as the baseline for comparison, as you will see further on. You can see here the water measured, the experiment number 1, we fill the water bath, which is this one in the picture, with pure water of 500 milliliters. We warm the water in the select temperatures of 22, 32, and 42 degrees Celsius each time. And we then submerge the fingers inside the water bath for 15 minutes, and we cut the length of the finger in which we submerged inside the water to be 5 centimeters, which we kept constant for each other experiment. Then we remove the finger and dry the surrounding area, and immediately photograph the wrinkled finger under the same conditions as the baseline photograph. You can move on. And here is the experiment number 2. We also fill the container with distilled water, but then we add specific concentrations of salt. And then we place the finger inside, which we used the same for the experiment, with the same conditions as earlier on. Then we remove the finger and dry the surrounding area gently, and immediately place the finger on top of the same paper towel, not the same paper towel, same kind of paper towel, and photograph under the same conditions as the previous one. You can continue. And here are different concentrations of salt, as you can see. Move on. Okay, so we first open the image in image A, we convert to 8-bit grayscale, and we then correct the uneven lighting in case there is one to minimize errors. You can move on. Here we run the edge detection plugin to detect the lines along the surface of the fingertip. We then mark the wrinkles along the surface of the finger, which also contains the fingertips. You can move on. We then analyze in Excel and do the sum of the total lines of the wrinkles. You can move on. Here you can see the final minus the length of the pixels before, which is before we submerge into water, and this is how we get the total length of wrinkles along the fingertips in pixels. So here are our different temperatures for the first experiment and our images. You can move on. Here is our graph. You can see that the lower the temperature, which is in the 22 degrees Celsius, we have a lower wrinkling in pixels. When the temperature increases to 32 degrees Celsius, we have a slight increase around the median value, and then as the temperature increases even more to 42 degrees Celsius, we can see a slightly more increase. You can move on. Here is our second experiment with the tonicity, 3.5, 15, and 26%. Here you can see the photos. And we can see that these values align perfectly, thus the osmosis theory is disproved. And you can move on, we will explain this later on. So both our conclusions are confirmed. Move on. And here are some possible errors. You can see, move on. And more factors to investigate would be the recovery time, the immersion time, different body parts or different fingers, and different temperatures. You can move on. And here are our final results. So wrinkling will occur more in the temperature change, supporting the active theory. Thus, as the temperature changes to 22, 32, and 42, the wrinkling will also increase in pixels. And in the second experiment, we can evaluate that the wrinkling will most likely stay the same in the case of tonicity changes, disproving the magnitude of the osmosis theory and the passive hypothesis that was disproved.
Finish your statement.
That's all.
You're out of time. Thank you very much. All right, now the team of the opponent can have a chance to ask some clarifying questions to the reporter, and then prepare. Go ahead. Timer for the clarifying questions.
Sorry, okay.
Let's reset the timer to the beginning, please. Oh,
sorry.
Are you ready to start?
Yes.
Okay, go ahead, please.
All right, how do you keep the water temperature controlled?
We tried to minimize it using the controlled water bath, as we said, which maintained the temperature above it had like a margin of...
Okay, so you use the hydrocalator? Yeah, okay, okay. How do you keep the length of the finger submerged in the water constant?
We tried to measure it with a ruler. It was around 5 centimeters, which we marked along the surface of the finger.
Also, do you believe that, yes or no question, do you believe that if we tested it on a person who had hair loss, they would wrinkle on their entire body?
What do you mean?
Yes or no?
Hair loss or...
Hair loss, so they don't have hair.
It only happens on glabrer skin, so no.
Okay. Also, did you test on people who had neurological damages?
Sadly not, because we couldn't get a sample of specific quantitative results of the nerve damage.
Okay, thank you. Can you go on slide 22? Is this line on your graph coming from theory? No, here, on your graphs, is this coming from theory?
Yes, we said that the higher the temperature, the...
No, I'm sorry. Can I ask?
What do you mean?
Does this come from an equation? Yes or no? Do these comes from equations or just best fit?
Best fit.
Okay. Also, did you take instrument error into account in the?
Yes, we took the image analysis. That's why we did the subtraction.
Okay. Thank you. Can I ask you another question? Okay. How do you define one wrinkle?
One wrinkle.
One specific wrinkle. Yes.
With one line that can be detected by image. And that's how we, in the first part, the image, the software detected the fingerprint and other lines of the finger as well. So we subtracted the final wrinkle from that, and that's how the wrinkle formed. Even one line of wrinkles which differed from the first.
Okay, thank you.
The first result is counted as wrinkling. Yeah.
Okay, thank you. Can I ask you another question now? How does age affect the results? Does the age of the participants?
We did not experiment with that, but it changed some
yes or no question?
Yes, it does. It does.
Okay.
But
also,
it was controlling.
Did you use the same participants' fingers?
Yes, we used the same person in many
Okay,
trials.
thank you. Did you also ensure that the skin had come completely to normal before testing again?
Yes, we waited a day before conducting.
Okay, thank you. Did you account for different skin types or skins with different types of water? Yes or no question?
No.
All right. And how did you make the salt concentrations? You said you had an error with the salt concentrations. However, this is your independent parameter. What exactly?
We said that we weren't exactly. There might be a small margin in the amount of salt that was added due to
Oh, so you did not measure it exactly.
We measured it exactly, but there could be we could have looked at the container probably, and that could have missed.
Do you believe that?
You're out of time. I'm sorry.
Okay, thank you.
Thank you. All right, preparation time for the team of the opponent. Quiet in the room, please. What a lovely idea. Okay, you're running short of preparation time. Are there any technicalities that need to be taken care of?
We have a bit of technical issue.
All right. Let's hold the timer for the time being.
Okay.
Are you ready to start?
Yes.
Okay.
All right.
Statement of the opponent.
All right. So I believe we're all familiar with this problem statement. So we're going to move on. Oh my gosh. Okay, so we believe that there was a pretty good introduction to the phenomenon as well as a theoretical explanation and the hypotheses. However, I believe that there could have been improvements on those particular things. The experimental setup and the experimental procedure were great, and the deductions and conclusions were relatively average, but I believe they were just okay. All right. So on the theory, we talked about osmosis and vasoconstriction as two different mechanisms for the wrinkly fingers, and said how they occur, as well as having investigating relevant parameters and having reasonable hypotheses. However, they mentioned tonicity and didn't really very well explain it. And they compared tonicity and osmolarity, which is a bit of inaccuracy in this statement. They also mentioned that it only occurs on hairless skin without specifically mentioning that it's just on finger pads or toes, because somebody who suffers from hair loss would have hairless skin all over their body, but it would not wrinkle. And the lack of well demonstration between the connecting theory and the results, because of the line fits used. All right, so for their experiments, I believe they did a very good job because they disproved one of the two mechanisms they tested as the problem statement wanted them to. And they provided graphs and they quantified the wrinkling, which is something that is very important and very good for this presentation. They also investigated the passive and active hypotheses, again, as the problem statement wanted them. Now, something that is very important, but they did not mention in their presentation, the problem statement mentions to investigate the properties of the wrinkled fingers. However, the reporter failed to do that without investigating maybe the friction components of the wrinkly fingers, which is the largest property that they have, because this is why they evolved in humans. All right, so there was a bit of a poor explanation on their controlled parameters and how exactly they controlled their experiments. And we believe that there was not really accounting for the instrument errors, and also because the reporter said they mentioned an error on their independent parameter. They mentioned their independent parameter as a major possible error, which I believe that could have been better controlled, especially since making salt concentrations is something quite easy. With a precise scale, you can make a very precise solution. I would like to suggest some improvements, which first of all would be to investigate the properties of the fingers to fully fulfill the problem statement, and also to have a mechanism to stabilize the hands and make sure that they were on the same depth for all the experiments, and also to use multiple fingers to take averages and maybe experiment on multiple people with variety of ages, skin types, and use a more broad variety of temperatures because we see very few points. However, this is an experiment that is very easily and cheaply conducted, so we can have them do this experiment more times, maybe leaving the fingers in the water for a little bit less time, so we can conduct an experiment or a broader range of temperatures. Also, one last thing I would like to mention is that the reporters mentioned nerve damage as one of the most important parameters affecting skin wrinkling, and I would like there to be a more in-depth experimental investigation of this parameter. Thank you.
It's time to start the discussions. Let's have the reporter back to the stage, please. Reporter. And let's have a 5-minute discussion. Hold on it, please. Starting now.
All right, thank you, reporter, for your very great presentation.
First of all, ask some questions about your presentation.
Well, I wanted to tell you, first of all, one thing. Why did you not experiment with the properties of the hands? As it says here on the problem statement, the different properties of the fingers or the toes. Why did you not experiment with them?
Yeah, we collected data to show how properties, the problem statement does not suggest different properties, it suggests the same. So we collected data to show how specific parameters such as temperature and tonicity affect those properties of the wrinkling fingers, which is the wrinkling in particular.
But you investigated the properties of the environment of the fingers and not the properties of the fingers themselves, which is a major fault in this problem statement, which we did not fully fulfill.
We experimented with the top part of the finger here, as you can see in the photo.
I understand that. However, you did not fully fulfill your problem statement in this case.
I also have to ask some questions for your presentation. You mentioned that we had uneven lighting and that huge error could be a result of our shadows that were in photos.
Could you please repeat the question? I cannot hear you.
You mentioned that the uneven lighting in our photos would have a major effect in the pixels and the analysis of the wrinkles.
Yes, having uneven lighting on the wrinkles
I agree with that. I agree with that,
some.
But before we calculate the wrinkles, we first apply the local contrast. As you can go to the analysis photo.
Okay.
To minimize that error and make the lighting homogeneous.
Also, in your theory, you mentioned that this only works on hairless skin without specifically referring to toes or fingers. Do you believe that any part of hairless skin would Also,
no,
the
glabrous
ears
skin.
Are
I meant the toes and the fingers. If glabrous skin, first of all, glabrous skin is only the. I don't I gave emphasis on the fingers and the toes. If another part of glabrous skin, for example, the palm of the hand is submerged in water, fingers won't be formed.
Well, this is pretty not the most important parameter. However, I believe this was an inaccuracy because
it's already predictable.
It depends on the type of skin.
I also have one more question. You said that.
Can I just ask you one question before?
You said that we hadn't investigated the potential of nerve damage in our trials.
Yes.
Though I clearly stated before that collecting such a sample to investigate this parameter is extremely difficult due to the fact that we needed quantitative analysis of the nerve damage so that we could be accurate enough and know that.
I believe that if you are mentioning it as one of your main parameters, you should be investigating it, and it is pretty easy to find a person suffering from those conditions. Can you please answer to my question now?
Okay, sure.
How did you? Yes, you said you took the first 5. Can I see your experimental setup, please?
Yes.
Can you experiment? No. How exactly? What's the tub you submerge the fingers in?
Can you go to the appendix? It's done, like in the last slide. Here you can see this is the inside of the water bath, and this is the water bath that we used.
All right, so this is a controlled water bath with controlled temperature?
Yes, it's approximate value. Here you can see the 30.2. And
30.2. You said you experimented with 32. Is this just for demonstration, or?
This is just for demonstration. It is not for the actual experiment, but to show you how the.
All right. I think here I can see the fingertips touching. I think the metal rack.
Yes, this is just.
Would that create that would create an indentation, which you might have made as a wrinkle.
To showcase the inside of the water bath, we did not calculate this.
Also,
because we placed the fingers above this.
So they were touching that?
No, they were not touching it. It was slightly above.
So then how did you control the fact that the entire hand was always submerged?
The entire hand was not entirely submerged. We calculated with a ruler 5 centimeters
Yes,
from here.
but you calculated with a ruler. If you you did not have stabilized your hand, which I believe would have created major errors.
We did it exactly. Yes, I can see your point, but we tried minimizing with as much as we could, but that could have been possible. But a slight one, it wouldn't affect our results massively.
I'm sorry, can you let me finish my statement? When you have it just submerged and just holding your hand like this with your own force, you're going to put it up and down. So some parts of your fingers will not stay fully submerged for all of those. For all that time. Also,
I think even if we stabilize the hand, it wouldn't have a huge difference in our results due to the fact that the hand would still be submerged in water and we wouldn't have removed.
Okay, also, why did you exactly...
Thank you for this discussion. I have to cut it off. Thank you.
Thank you.
And now the reviewer can step into the game and ask some clarifying questions to both of the previous parties.
Okay, take this.
Okay. Thank you. For the reporter, did you make sure that the initial hydration of the participants' hands was controlled?
Yes,
Yes, so yes.
We, as I said earlier, we waited 1 day before testing each different parameter, and we,
thank you.
We made sure that the moisture of the hands was
for the opponents,
was zero.
You mentioned that you would like to see some more parameters controlled. What would be some parameters that you would like to see?
I would first like to see that the hand is always has a rest, something to rest the hand on, so it is always on the same exact height. And also because the reporter said that they poorly controlled the salt concentration, even though it was an independent parameter, we would like to see that better controlled.
Okay, you also mentioned hand stabilization. Why do you think that's important?
That's very important because when you have your hand just holding it by your own muscles, it goes up and down. You cannot keep it stable, and it might also take out the part of the fingertip which you are measuring, so it spends less time in the water.
How would you measure? How would you keep it stable?
I would maybe add a pile of books or something tall to just keep the hand like this, so we get above the water bath.
Okay. Thank you.
Have it always like this.
Okay. For the reporter, how much salt did you add? And can you explain the percentages? Because you kind of glossed over them.
We used different concentrations. Can you go to the second experiment? Here. No, the next slide. Here you can see we had a concentration of 3.5%, and we used 17.5 grams in 500
thank you.
Of water, a low, a medium, and a upper saturation.
You also mentioned that you only dried the surrounding area of the fingers. Why is that?
We did not dry the surrounding area of the fingers. We dried the entire finger that was submerged in water.
Okay, thank you.
We can ensure that.
How much time did you wait for the finger to dry between your experiments?
At least we said that we waited the day before testing other parameters.
Okay, and did you only use 1%?
Thank you. We have to interrupt you. All right, preparation time for the reviewer, please. Quiet in the room. Quiet, please. All right, the reviewer is running short of preparation time, and we have apparently some technicalities to be taken care of. That normally shouldn't happen. ready for the next stage, but hold on the timer, please. Are you ready to start? Okay. We have a jury member asking us to hold on for the time being. All right, ready to start? Go ahead, please.
Okay,
give us the review.
I will be doing the review. Okay, I think we're all familiar with the problem statement by now. So let's start with the reporter. Okay, some good things. The experimental key points were very well analyzed, such as osmosis, vasoconstriction, tonicity, etc. They had a good introduction to the phenomenon. They included photos from the experimental setup and experimental procedure, as well as how they calculated the wrinkles. They also answered the opponent's clarifying questions accurately, and they explained why both the active theory and passive theory were approved or disproved. Now, for areas for improvement, they didn't use multiple people for the experiment, which obviously limits the accuracy of the results because skin varies a lot between people, so by testing only one person, the results would be way too generalized. Now, they didn't include other factors such as hydration, previous contact, skin moisture, and they didn't mention how they could affect the experiment. They also had no analysis on wrinkle depth, which is very important, and in the theory, they mentioned temperature twice, and one time he said that it didn't affect wrinkling that much, but that included and the theory experiment about temperature. They also had no analysis on salt concentration percentages, and they didn't check for neurological issues of the participant. For the opponent, they successfully pointed out that the reporter didn't investigate the properties of the wrinkles. They asked targeted questions to indicate any concerns of theirs, as well as to test the accuracy of the experiment and procedures, such as how do you keep the temperature controlled, and if they checked it on different skin types. And they also asked questions based on a clarification of certain points. Now, areas for improvement. They didn't mention the fact that the initial state of the hand was not controlled or mentioned in any way. They failed to bring up the fact that the test was conducted with only one participant. They spent way too much time focusing on unneeded, irrelevant possible scenarios, and they failed to mention that the conclusions were not analyzed enough. And they also didn't explain why parts of the presentation were average. Now, for the points discussed, the opponent asked about what properties of wrinkly fingers were tested. The reporter said that they tested parameters that affect the properties of the wrinkles. Our opinion, we agree with the opponent because we believe that the properties were not actually tested in the experiment. They also asked about their theory of wrinkles only being on hairless skin. And the reporter said that it only applies for fingers and toes. We believe that it's not that important as long as the parts tested were hairless. Now, they pointed out that the fingertips touching the metal rack might have implications. The reporter said it was just to show the inside of the water. And as long as, for us, as long as the fingertips don't touch the metal rack, the results wouldn't be affected. Now, they also said that the ruler is not an effective way to calculate the finger that is submerged, and the reporter said that they used a ruler and they tried to keep the part that is submerged constant, and we agree with the opponent. Thank you.
Thank you very much. All right, some final words from the opponent first. 1 minute. Starting now.
Thank you both to the reporter and the reviewer for this amazing fight and discussion. I would first like to point out some things that the reviewer said that focusing on the fact on people with hair loss. I believe that was just a counterexample to the reporter's theory, who said that it only happens on hairless skin, which yes is true, but it is far too general. Also, for the reporter, I believe there could have been some improvements made in your presentation, namely fitting the problem statement, making an experiment testing the properties of the fingers, so you could have fully had that problem statement. And also, you could have better control the submersion of the hands in the water by just adding a pile of books so the can could rest on. That would have been far than enough to make this more accurate. All in all, this was an amazing fight. Thank you very much for this discussion.
Thank you for this statement. Big applause. And the final words from the reporter. Hold on with the timer until he gets on the stage. You have the word, 1 minute.
First of all, I have to thank both the opposing and the reviewing team. And I have to refer to both the opponent and the reviewer. You said that a stabilizer would be would be necessary to maintain this control parameter. I agree with that, but also we submerged the finger inside the control water bath, which was difficult to do due to the structure of the machine itself, and that could have also affected the temperature, because the finger would have been outside of the water somehow, in some parts, if a stabilizer was going to be used. Also, the salt concentration that the opponent mentioned was controlled, and we tried to minimize that there. We're using a high accuracy scale. Also, the reviewing team mentioned that we talked about the temperature 2 different times in the theory. Yes, because the first one was the active response, the vasoconstriction, and the second one was the osmosis theory. So we had to mention that. And lastly, the reviewing team mentioned that we had not accounted for the length or the depth of the wrinkles, which we did by calculating the pixels of the wrinkles. Yeah,
Thank you. Thank you. All right, questions from the jury. Short, clarifying questions. Go ahead. Anyone?
Okay, so my first question is to the reporter. Can you explain, please, when taking the images of the, what measures did you take to ensure consistency across different measurements?
We photographed the. Can you go to the photos? Here. You can stay here. The previous slide. Next slide here. We tried taking the photos with the same zoom in our camera, also the same distance from the camera, and the same point which we had marked on the finger, which was exactly the 5 centimeters that we mentioned before.
Okay, and then again, quickly, how long did you maintain the finger submerged?
15 minutes.
Okay. To the opponent, can you please re-explain quickly your point on why the stabilization will impact the results?
Well, yes. We said that it would be a good idea to stabilize the hand, because here on the reporter's experimental setup, we just see the hand being held up by the person's arm, and in this case it can go up and down unconsciously because it's 15 minutes, it's a long amount of time, and it can touch the racks or get out of the water, those 5 centimeters that are being measured. So to have a more accurate result, we would have the hand resting on top of something, so it does not move around.
Do you think that the extent to which the destabilization may affect it is significant?
I believe it could be significant, and also maybe because it's not controlled. That is the thing, because we cannot see how much it is every single time. So it would make it difficult to determine whether or not it would be irrelevant.
Okay, that's fine. Thank you.
Yeah, just a quick question to the reporter. In your experimentation, you find out that tonicity doesn't really matter about the wrinkling of the finger.
Yes, in the passive the osmosis.
In your theory, you said that it might affect?
In the vasoconstriction theory, not the osmosis part. In the osmosis theory, we said that how can I say it? Different tonicity values wouldn't have affected the result, and the wrinkling. No, this is for the vasoconstriction. Sorry. So different salt levels wouldn't have affected the result because this is a response of the nervous system. It's an active response of the nervous system. So different values of salt levels wouldn't have affected the wrinkling in some anyway.
Thank you very much. Thank you.
A quick follow-up question on that.
Yes.
You said in your theory that it actually slows down, the tonicity slows down you had it in your presentation for the vasoconstriction. So can you explain why is that?
Not in the active response. You mean in the osmosis theory in the active response?
In the active.
Can you go to the active response slide? Next one.
Here, however, the process will be slowed down. Can you explain why that is?
Okay, due to the fact that how can I say it exactly? The process will be slowed down. The fact that there will be like I don't know how to explain this exactly, but I don't know. That's
Okay, thank you. First of all, to the opponent, you made the case in your discussion that the reporter should have experimented with different properties of the finger itself and not just the environment.
Yes.
So I ask you, with what kind of properties of the finger would you experiment with?
I think the main one would be the friction of the fingertips, because this is the reason these, like on the surface, because this is the main reason this mechanism evolved, so to have better grip.
Is an inherent property of the fingers?
Not an inherent property of the fingers, but I would like them to experiment with the differences in the coefficient of friction of the fingers when they're wrinkled versus when they're not, and maybe when they're put in water for a different amount of time.
Okay, thank you. And one for the reporter as well. In your results, you had some error bars in the... let me explain. So you didn't do any trials, so this is not standard deviation. And image J...
What do you mean by no trials?
How many trials did you have for...
We had 3 trials for each value. For example, here we had 3 for the tonicity value of the first salt concentration, the second, and the third.
Okay, so how exactly do you calculate the...
Standard deviation.
So it's only that from the trials, from 3 trials?
Yes, and we tried minimizing the errors from the image analysis, the image J, as we said that in the first, when we took the baseline photo for comparison, the image J software detected also the fingerprints and the different lines on the fingers that are already evident. And so we divided the final wrinkling from the initial wrinkling.
Okay, thank you.
So that's how we found the pixels of the wrinkling.
Okay, a question to the opponents. So you mentioned an experimental investigation of the neurological damage. So how would you check that exactly?
Well, I believe that since they mentioned it as one of the main contributing factors, they should have either had a very detailed explanation why they couldn't do it, or actually did it. Maybe they mentioned there are some specific neurological diseases that have a big impact on these, such as Parkinson's, and we have people who suffer from these conditions in our environment. So maybe we could have conducted experiments with their hands as well. So check for whether or not that affects it.
Okay, thank you very much.
Mr. Mate?
So let's get to the grading part. Thank you very much. You can take your seat. Big round of applause for everybody. The jury shall write down the grades, but they are not going to be announced. I'll just make sure that all of the forms have been filled and signed. No rush, take your time, make sure that you evaluate the knowledge of the participants in an objective and clear manner. Quiet in the room, please. This is the preparation time of the jury. at the final. As you have figured out, it's important for us to have many jurors because most of them are different specialists in different fields, so that we can have a better averaging of the grades. All right, are we okay? One person on the front row. Is the back row ready? Okay. Okay, dear jury, you are running out of preparation time. All right, everybody back, ready in the back?
Are you done?
Front row ready? All right. Well, thank you very much for taking part in this first stage. The grades will not be announced as per, the request of the organizers. They will be taken care in later on in the calculation, and the winners will be announced. Let's take a break of how many? 5 minutes. Thank you very much for being present here. Take a good rest and be back for the second half.
So, Alicia, the first stage was concluded. What do you think about it? How do you think it went?
The review was really good. It was an epic fight, and the discussion was really interesting and very intense. Good job, kids. Very good.
Nice. Thank you, Diveri. We have also here with us Demostheni. Hi. Tell us the name of your team and what do you think of the first stage and the tournament in general?
So my team is Team Vexora. The half of my team is here, and the first stage was pretty good. I really enjoyed it. I really like the report of the team that reported, Absolute Zero, and I'm forward to looking the other two stages also.
Good, great. Grigoria, don't leave. We want your comment. What do you think of the tournament so far?
We started very good. I think every team had a great performance, and we're waiting for the other teams. Can't say big words at the start.
Yes, that's true. Mirto will give us a comment now. Who's running? No, she won't. Oh, she will. Mirto, what's your favorite color? No, what do you think of the tournament so far?
I think that no one is watching this live stream. Okay, I think it was a great tournament. I think that I wasn't expected to get interviewed, and I think the teams did great. I liked the first fights. I liked the semifinals. It was very exciting. I think the presentations that they did a great job. I don't know. I can't wait to see who wins.
Great. Thank you for your comment. Miss Nada, would you like to be interviewed?
Of course, yes.
What do you think of the tournament so far? No comments for the final since you're a judge.
Of course, yes. I mean, it's been fascinating as always because we can see how passionate they are and the teamwork. All these people spend time together. They're passing each other the notes. So I think these are the friendships forever. Mm-hmm. So it's fascinating to be a part and seeing teenagers building right skills in life.
What was your favorite problem that you saw, not in the finals, and the tournament so far presented?
It's very statistically uneven because I see some problems twice, some of them never. I have to admit that the spider web was quite an interesting one. It made me think as well, why is the spider web so perfect? How can it really happen? So we could see sometimes there are general ones, spider web, butterfly, chemical solutions, very complex, but spider web made me want to read more about it behind.
Great, thank you for your comment.
Thank you.
Mr. Doulakis now will give us a comment, or not. Mr. Fedra? Guys? Miss Fedra? Yes, sorry. Dimitri? Comments. What was your favorite problem of the tournament? Not of the finals, you cannot comment on the finals, but the one you saw in the preliminary rounds.
Electroplating.
Why is that?
Yeah, it was nice.
Thank you. The captain of team Outliers, yeah. Do you want to comment on anything on the tournament?
Yes. Lab Legends, very good.
You like Legends in this stage? Great, thank you for your comment. Guys, do you want to comment on anything of the stage or of the tournament? No? No comment? Not right now. Melina. Yes, in the microphone. Kala. Joanna. Oh, okay. You're in the team as well, right? She's not. I wanted to comment on your mascot. It's Tweety. Why is it Tweety? Is it symbolic of anything? Okay. Okay. Nice. Iliana, do you want to comment on the tournament so far?
Yeah, it's a very nice tournament. I really like it.
Great. Are we ready to start the next stage? Are we preparing for the next stage? Good. Oh. So, we're in the finals. We will begin to get ready for stage number 2. Everyone that's participating, please take a seat. So teams, juror, take your seats so we can start stage number 2. Absolute Zero, you're all here. Ileana, you're all here. Lab Legends, you're all here. So we're missing revolutionaries. So we're missing team revolutionaries. Please take your seats so we can start. On this stage, Team Lab Legends will be reporting problem number 14, rubber mechanics. No, you don't report. You were a viewer, so you now oppose. It's going up. Team Revolutionaries will be opposing and Team Absolute Zero will be reviewing. Is everyone from Team Revolutionaries here? Great, so we have a full house of the teams. May the jurors take their seats. Kaimakis. Great. So, if anyone from the jury is here, everyone from the teams is here, I yield the floor to Mr. Matev. Have a nice stage.
If there are any team members missing from the room, let's have them all here. And we are beginning with the format for the second stage. In the second stage of this battle, we're going to have problem number 14 presented by the team Lab Legends. Make sure that everything is prepared. Let's have the reporter up on stage and let them have us know at the moment when they are ready to start so that we can proceed with the report. If there are any technicalities that need to be taken care of, make sure that you get everything handled and right, and be ready for the report.
Okay.
All right. Are you ready to start? Let me know when you're ready to start before I say about the clock.
I'm ready.
All right. You have 8 minutes,
yes.
Starting now.
Thank you. This is problem number 14, rubber mechanics. So the problem statement says, formulate an experimental problem involving stretched or twisted rubber bands. And our problem statement is that exposing rubber bands to high temperatures can alter their composition, demonstrate how boiling a rubber band can affect its stiffness through a controlled experiment involving oscillating rubber bands. So a rubber band is a closed loop made of elastomic polymer that exhibits elastic deformation, meaning it can be stretched under applied force and then return to its original shape after the force no longer exists. Elasticity is the ability to undergo reversible deformation in the rubber band. So the elasticity of the rubber band is due to the molecular structure of elastomic polymers. The polymers are very large molecules formed by chemical linking of repeating smaller units, the monomers. The monomers are simple molecules that join together to form long chains. The polymer chains exist in an amorphous state, meaning that they do not have any regular repeating geometric arrangement, unlike crystallic solids. Instead, they are randomly arranged in space, and this random arrangement allows the material to deform easily without breaking. So when a tensile force is applied, the polymer chains align, uncoil, and adopt a more ordered orientation. So, weak intermolecular forces are attractive forces between molecules or polymer chains. They significantly weaker than intramolecular bonds and hold molecules together while still allowing them to move and rearrange. And that's because the weak intermolecular forces allow this to happen by temporarily giving way as the chains move. So, in order for the attraction to happen, the molecules must be very close together, and there must be a relative stability in the proximity, meaning the molecules are not moving so violently. So, the weak intermolecular forces are important for rubber elasticity because they give the material cohesion without rigidity. So, in addition to weak intermolecular forces, there are cross links, which are few but strong chemical bonds connecting polymer chains. They prevent chains from permanently sliding past each other, maintain cohesion of the material, and ensure that deformation is reversible. So when we hit the rubber band, the thermal energy translates into kinetic energy of the chains, meaning that because the chains move so violently, the weak intermolecular forces are weakened completely, and the only thing that combines and keeps the chains together are the crosslinks. However, because of the high kinetic energy and kinetic activity of the chains and the absence of the weak intermolecular forces, these crosslinks may break, meaning that stiffness is decreased, and even if the rubber band cools down, not only the crosslinks, some may not exist anymore, but the chains have a new arrangement and with a looser configuration because the crosslinks haven't restored fully the structure of the chains. So the stiffness of the rubber band is decreased permanently. So if we increase the boiling time, as I explained to you, the stiffness will be decreasing up until a point where the phenomenon of thermal degradation happens. Thermal degradation is defined as a process whereby the action of heat or elevated temperature of a material causes loss of physical, chemical, or electrical properties, meaning that there is a limit to the rearrangement that leads to looser chain configurations. So, as you can see here, a harmonic oscillator contains the Hooke's law from this equation, and from this equation we can get the sinusoidal equation of the position of the position of the oscillator. And in harmonic oscillator there is no energy loss, but in a realistic experiment we have a damped harmonic oscillator where energy loss exists, and we have this equation, and the blue from the main equation on top there, we can create the blue equation, the position of the oscillator, and also can calculate the stiffness of the material. So we made a hypothesis saying that the longer the rubber band is exposed to high temperatures, the less stiff it will be, and stiffness will decay with boiling time up to a point. So this experimental apparatus, the rubber bands were from the same box, 80 millimeters length, and the rest of experimental apparatus with weights and stuff like that. So each rubber band had 250 grams. We released after it had 8 millimeter length, as shown in the video. We boiled it for different times, and the diameter of the tube that you see there is 1 centimeter larger than the diameter of the band, and it is because we use it in order to contain the energy that is lost if the oscillator system swings left and right. So this way we can contain the energy that has been lost. So we use a tracker to measure the movement of the rubber band. Here's experimental setup. We use levels in order to make sure that everything is horizontally aligned. And the dependent parameter is boiling time, the dependent is stiffness, and the control is the initial rubber band properties, the weights, the releasing point, and tube and base structure. But not all rubber bands have the same stiffness, even if we took it from the same box. So we did a small experiment. This whole structure has the same weight, but if you touch a rubber band, then the value of the scale will be decreased. And if we compare two rubber bands and the value are the same, it means that they have the same stiffness. So then after categorizing the groups, we take the groups with the most rubber bands because we need rubber bands to do the experiments. So after we boil the rubber bands, we put them in water, then a spoon above it in order to contain the rubber band fully underwater. So after we get our data, these are experimental data. We fit it. This orange line is the fit. It is the theoretical values of a harmonic damped oscillation. And as you can see, they are almost perfectly aligned with our experimental values. This means that our oscillating rubber band follows the harmonic damped oscillation, allowing us to use the equations of the harmonic damped oscillator to calculate the stiffness of the rubber band. Fitting all the first part avoids deviation from the real damped harmonic oscillator because the smaller the movement, the more error that can be done in the tracker. So first of all, we have 5 rubber bands not boiled in order to measure the error. And after doing this whole process I explained to you, I calculate the stiffness. The average stiffness is 40.8 with an error of 1.3, which is calculated with standard deviation. Now here I will show you, if you pay close to the end, you will see that the amount of oscillations in the same period of time will be decreasing more quickly. Okay. As you can see here, the stiffness is also decreasing. And here you can see a graph showing that the higher the boiling time, the less the stiffness decreases up until a point where the boiling time no longer plays a role. So our hypotheses were confirmed. Yes, Ella? Next slide. So there is a small manufacturer errors, even though we did the whole experiment regarding this. Small movement of the membrane plastic tube, even though we secured, may play a role. And the rubber bands were enough during oscillation, but these errors should be very minimal. Thank you very much.
Thank you.
Conclusions.
Yeah, if you have any conclusions, please have them on the screen.
And our bibliography.
All right. Thank you. Thank you. All right, let's have some clarifying questions from the opponent, please. Ready to start? Timer starting.
Did you test the stiffness before the experiment of the rubber band?
Yes, as I showed you, with the small structure and the rubber band that placed on top and the scale values.
So when the stiffness decreases, does that make the rubber more vulnerable to break?
No, because I have not experimented with such extreme pressure in order to break it.
Did you use Hooke's law while stretching the band?
No, actually Hooke's law is a part of our harmonic damped oscillation, so actually calculating K contains part of Hooke's law.
Did you account for damping in your experiment?
That's the whole process. We measure the energy loss, and with this equation we measure the stiffness.
But you did not add it to your experiment?
No, I did in my experiment. I used a harmonic damped oscillation.
You did not add it to your theory?
I added in my theory, as you can see before, the equations about the harmonic damped oscillation.
Okay, but not about damping. Okay, here, thank you.
The
How
next
many
one.
parameters did you test in the end?
One parameter, but with many time.
How many times did you conduct the experiment?
It was for the first with no boiling, 5 rubber bands, and the rest we did it one per time. The one for 30 seconds, one for 1 minute, one for 2 minutes, one for 4 minutes, one for 6 minutes.
So what were the boiling temperatures?
100 degrees Celsius.
All of them, like you said?
Yes, it was boiling water.
Okay, yeah. So, and like, you did that based on your theory, right? Like
Yes.
Okay, yes.
We
And
boiled the water and we kept the rubber bands there for a specific amount of time.
Test, you mentioned that you had a lot of rubber bands. Did you test all the rubber bands?
Yes, all the rubber bands from the box.
And how many exactly did you use?
I used 13.
13 only?
Yes.
Okay, yes, thank you.
Yes, but it was many experiments.
And the stiffness that you said you measured, did you use Hooke's law to measure that?
No, I measured it with another experiment that I showed you with this thing in order to see the relative stiffness between two different rubber bands to make sure that from the beginning the rubber bands were
Hooke's law was not about that. Okay, so Hooke's not, yes or no?
Hooke's law is used later, not on this part.
Yes or no, was not about that part?
Not about that part.
Okay, so what did you categorize the rubber band as?
Synthetic rubber.
What?
Synthetic rubber.
Okay, and why not natural?
Because synthetic rubber, we found it more accessible because we wanted it in large quantities.
Okay, so you purchased large quantities of synthetic rubber, tested all of them, right?
Yes, as you can see here, I have categorized the rubber bands according to their stiffness before I did any experiment. And of course, I took this value because they were more and I need as many rubber bands as I want.
All right. You have some more time. Are you finished? Now you don't.
One final question. Were all the
Very
rubber
short
bands the
one,
same
please.
width length?
Yes, all 80 millimeters.
Okay, thank
Short
you.
answer. Thank you. All right, preparation time for the opponent. Quiet, please. Okay, you're running short of preparation time. Are you ready to rumble? You're out of preparation time. Please start. How much time do you need? Can you start right away? Timer starting.
Sorry, we have some technical issues that cannot upload.
Oh, you do? You should have told us. Let's pause the timer,
Can
please.
you pause the...
Oh, okay.
Okay, we're two revolutionaries and we're the opposition team for this experiment. First of all, we would like to talk to you about the reporter's theoretical module. Okay, so the introduction to the phenomenon was pretty good. Moving on, the theoretical explanation was very well detailed and we could understand most of the parts. However, we found that the experimental setup was a bit lacking. The experiment was also a bit lacking. The data analysis was pretty good. We saw a lot of graphs and the conclusions were average. Okay, moving on to the theoretical model. They had some good theory for the experiment. They explained keywords such as rubber band, elasticity, polymers, molecular arrangements, and weak intermolecular forces, and thermal degradation pretty well. It was really good and easy to understand their theory and what was their thought behind this experiment. They also had visual aid for theory and a lot of mathematical formulas, which was easy to keep up. They had photos of experimental apparatus and experimental procedure, which was also very easy for us to understand. Okay, moving on for areas of improvement. They had no clear explanation of the formulas or laws that they used, and if they were used in the experiment, because also they had no conclusion to correlate their theory with their experiment. So it was pretty hard for us to keep up and understand what was going on in that part. They also had no explanation on the images used on thus theory, and not clear how Hooke's law applies, why, and how it was used. Moving on, we want to talk about their experimental method and results. So they did many experiments to ensure more accurate results, which is pretty good if you want to test an experiment such as that, which has a proposed problem statement. They also explained why their hypotheses were confirmed. They had a clear explanation of the experimental procedure, setup, and data. They used many photos and many graphs, which was pretty easy for us to visualize the whole context and their conclusions. But again, since their conclusions were not written down in a more concrete manner, it was pretty hard for the opposition to understand. So also they mentioned and explained possible errors. However, for areas of improvement, they didn't analyze their conclusions that much due to time constraints. They only explained the graphs and results, and they pretty much closed over most things. And they had no specification if mathematical equations were used later in the experiment and how. So it was pretty hard to understand. Okay, so some suggestions for further improvement for the reporter. You should include detailed conclusions as to why the hypothesis was confirmed, because the opposition needs to understand what happened with your results, why that correlates to your theory, and why that answers your hypothesis correctly and your proposed statement. And also you should try to be more clear about what your goal in your experiment is, because it was pretty hard to keep up with what was going on in general. Thank you so much.
So I want to start with my conclusions. Yes,
we just wanted to say that it was pretty hard to understand most of your conclusions. Can you go over that?
Yeah, I want to do just like that. So if you go to the conclusion slide, please. So we tested two different things.
Yes.
So the first conclusion is that Hooke's law is valid for rubber bands. Yes,
okay.
I answer to both of your questions. It is applied for rubber bands because both harmonic oscillation and damped harmonic oscillation contain Hooke's law, which is used to extract K and the stiffness.
Okay, but can you tell me, because it was hard to understand, can you tell me exactly in your experiment when and where did you use Hooke's law?
Okay. the Hooke's law is used, the diagram, and as we saw, our theoretical values and experimental values match up perfectly, so we can use the harmonic damped oscillation equations to calculate K. So these equations contain...
You used Hooke's law to calculate damping, is that what you said?
No, I used equations of the harmonic damped oscillation contain Hooke's law, are based on Hooke's law. So using their equations, it's like using Hooke's law.
But aren't you aware that Hooke's law does not apply for rubbers?
It does apply for rubbers, and I
Can you
showed
explain to me how?
Yes, if you go to the extracting K slide, as you can see, my theoretical values, the feet are the theoretical values of the harmonic damped oscillation.
So you did
which
use Hooke's law to measure oscillation, right?
It is used, yes.
Okay, yes, okay, thank you.
Because the theoretical values and experimental values match up perfectly.
Can you also, like, at the beginning, explain a bit more further, because it was hard to understand, how did you measure stiffness?
Measure stiffness,
you saw,
okay,
like,
okay.
You saw it as a
So,
machine, but it was like,
you can
how did that
go
measure
previous
stiffness
slide.
exactly? And
Previous
also,
slide.
did you measure the stiffness of the rubber bands before you boiled them as well?
No, because if I let them oscillate, then the stiffness may change. So the most accurate way to do that is the thing I showed you.
But if you said that all the rubber bands were the same, as you said, couldn't you have tested like one rubber band for before the experiment and then the others for after?
Yeah, that's what I did.
You said the results were the same.
After I categorized the rubber bands, after I categorized the rubber bands here into many groups, each category has the same stiffness using this way. You understand this way?
Yes.
Okay.
No,
So
can you explain a bit more this thing?
I have a scale. I have this bottle of water and the thing that has a certain
So the bottle
weight
of water
amount.
is like the weight that you use.
It's the weight. It doesn't matter how the amount of weight and the value. It just matters the relative value between two different rubber bands.
Okay.
So if I add a rubber band there, you understand that the value is going to decrease.
Yes.
So if I do that with different rubber
But
bands
you
and I
only
get the
did
same
that.
value
You
there,
only
it
did
means that
that
they have the same
after.
stiffness.
You only did that after the boiling, right?
No, meaning that for every click I do, after following the oscillation, I get the points of
And which
the
mathematical
key and
formulas
C.
did you use for here?
The damped harmonic oscillation, the other one that I showed you before.
And
To
can you
extract K.
also, can you please explain a bit more on what you did in your experiment? Like, why did you boil the rubber bands? We understood, but we want you to elaborate further because you skipped through it a lot.
Elaborate how I did the experiment.
Yes.
Okay.
And what did you try to prove with that?
I tried to prove that if I
The
boil
stiffness, like your hypothesis,
the stiffness decreases the more I boil it, up until a point where boiling no longer plays a role because of thermal
And
degradation.
how exactly did you conduct the experiment? Can you show us again?
Yes.
Unfortunately, I have to cut you off. Thank you very much. That was a nice discussion.
Thank you.
And let's have the reviewer ask some clarifying questions that will make it even more interesting. Clarifying questions to both the opponent and the reporter. Go ahead, please. Starting the time.
For the reporter, did you measure the temperature at which you
They were all at the constant temperature when I did the experiment,
So
but what changes is the amount of boiling and the...
You changed the time, only the time in the pot?
Yes, because boiling happens at 100 degrees Celsius, so if I change the time...
Thank you. How many times did you repeat each change of parameters?
So for the no boiling, I did 5 rubber bands to calculate the error for the 1.83 that I showed you. And then after having the same rubber bands with stiffness, I did 1 per category.
Can you go to the graphs for these 5 repeat?
Graphs? Here.
Here, yes.
Yes, here
So
you can see.
these are the 5.
The 5 graphs.
5 times.
Yeah, the 5 times of the not boiled.
How did you calculate the error bars for each time?
These error bars. Yes, these are seen plus minus 2 pixels in the tracker that I used, because I used a tracker to measure the points, the y-axis.
For the opponent.
Okay.
So would you prefer an experiment with a natural band?
No, we just wanted to clarify because they mentioned it in the theory.
Okay, thank you. For the reporter, for its repeatment, did you change the material? Because
No, it was all the same material, all synthetic rubber
so you
from the
didn't
same.
investigate a different material.
No.
Did you change the rubber band because every time
Of course, I used of course, I changed the rubber band for each time, and I specifically mentioned that I didn't calculate K with the same way as the
others. Can you show me a
others.
bit your experimental setup?
Okay. So
also for the where you put the rubber bands in the pot, did they?
Here.
When you heated the rubber bands in the pot.
Okay.
Unfortunately, you have run out of time.
The rubber bands were all under the water. Not a single.
Thank you. Thank you.
Did you have contact with the pot?
Thank you. Let's cool it down, and you can get back to your team for preparation time. Preparation time of the reviewer. This is the preparation of the review. All right, this is the end of the preparation time. You can start. After the technicalities are over. Reset the timer, please, and let's start.
Hello, everyone. My name is Anastasis Nikiforidis, and today I'm going to be reviewing problem number 14, rubber mechanics. I believe the problem statement is familiar, so I'm going to skip it. Here is an overview of the solution. And let's start with the report analysis. Some strengths we noticed were that they explained the elasticity through the molecular structure of the bonds. They had a nice proposed problem statement. They had explained the intermolecular forces happening in the rubber band. They had good analysis of how the temperature affects the kinetic energy, and they also had impressive visuals. So as for the problem statement, as for the areas for improvement, they did not explain how they ensure the force they apply on the rubber band is reversible and kept constant. They only investigated one parameter, which is the boiling time. The boiling point of the band's material was not mentioned, and neither was whether the water was already boiling when they put the band in the water. And they didn't mention if and how they kept boiling of the rubber bands at a constant temperature. As for the opposition, they questioned on which part of Hooke's law was applied. They correctly questioned what the boiling point was. They correctly pointed out the lack of correlation between equations and experiment, and they had clarifying questions actually clarified the experiment. As for the areas for improvement, they asked why they didn't use natural rubber band, which is something irrelevant, as the same type of rubber band was used throughout the experiment. Also, there was no mention of the lack of control regarding temperature, so once the water hit boiling point, temperature was not maintained, and they didn't criticize the reporter for only conducting the experiment. So as for the discussion analysis, the first point was Hooke's law used in the experiment. The bond asked when and where did you use Hooke's law. And the reporter replied, we use the harmonic damp oscillations to find K so that we can apply Hooke's law. And then the opponent also asked, but this law doesn't apply on rubber bands. And the reporter said it does. We agree with the reporter. The law does apply on rubber bands, and the method to find K constant is accurate. Second point, there were used no explanation of the formulas. The opponent said to elaborate on your equations, as you didn't do that early, and say how you use them. The reporter said they were used to calculate the stiffness K, and our opinion is that the reporter did explain how they use them, and the analysis in the report. So some of the suggestions to the reporter, you should be more clear on the correlation between the theory and its equations. You could have tested natural rubber bands in comparison to artificial ones. And you could also have tested how different parameters affect the results. And as for the opponent, you could focus more on the experimental lack of control conditions. Thank you.
Thank you very much. Final words from the opponent, please. 1 minute. Hold on for the time being. All right, time is starting.
Okay, so first of all, thank you all for this fruitful discussion. We believe that the reporter did a really good job conducting such an experiment. And even though we had doubts at the beginning, we believe that our discussion was pretty fulfilling for both teams. And we answered most of our questions that we had. And we also expressed our opinions about many things. But then the reporter could also say why they were correct, and it was a pretty nice discussion. Also for the review, they mentioned that we failed to talk about how temperature was not constant about other control parameters, but we definitely did bring that up in the discussion, and the reporter clearly stated how they kept everything constant, so we don't see how we missed such a thing. And also they mentioned that we talked about natural bands. That was only in a clarifying question, and after it was clarified that they did not, we moved on and never mentioned it again, so we don't see why it was such a big point in the presentation and overall in their questions. Thank you very much.
Thank you. And finally, some last words from the reporter. For another minute, ready to start? 1 minute starting now.
I'm ready. Thank you for this amazing fight. I want to clarify some things about the repeatability. I want to say that even though I used one per different amount of time in boiling, the tracker gives a large amount of data to fit in the theory, so it was a good control of rubber bands. And as a result, we got that the experimental and theoretical values match up perfectly, so this does not leave a room for errors. Also, I want to state that, as I mentioned in my report, I placed the bands in the boiled water, not before the boiled, so it works as a system. And also, I think that this one parameter, without using natural bands, fulfills the problem statement, because natural bands would be a whole other experiment that I didn't investigate right now, but it's something that does not correlate with my experiment right now. Thank you all very much.
Thank you very much. All right, big round of applause for everyone. Questions from the jury?
Yeah, quick question to the reporter. The presentation? I'll do it myself. Okay, can you go to the slide where you have your measurements of K, of the stiffness constant?
Okay. You mean the other one with the...
Yeah, how much was the K for all the rubber bands?
So, the average from this fight is 40.8.
Was it the same for every single
No, it was the average. And the error was calculated with standard deviation.
Okay, thank you.
I want to ask the reporter also. You said you categorized the rubber bands and you said which one were identical. So how did you make sure that they were identical? How did you know how to categorize them?
If you go to the ones that categorize the rubber bands with the... Go above. The categories of this one. So I use this, and when the values here are the same for two rubber bands, I categorize them into one group.
Yeah, but you said that you didn't use the ones that you measured the K. They weren't the ones that would use the experiment. You didn't boil them.
I hadn't used them anywhere. This is the first time they will be used. And I did that this way because if I did the oscillation trick to calculate the K, then the K would differ from the starting K, because while the oscillating, there's a chance that a small deformation happens. So this is more accurate in order to do that.
I have a three-part question. First of all, how many trials did you do for each rubber band?
5 for the not boiled ones, and then 1 per each duration time.
Okay, I mean for the exact same rubber band, not the.
From the one, so that no deformation happens.
Okay, thank you. And also, after how much time after hitting the rubber bands did you use them for the?
Almost as fast as I could, but it does not play a role. It does not play a vital role because the damage is already permanent, so I don't need to test it while it is still has high temperature. Because as I explained in the theory, the damage with the cross links and the weak molecular forces is already done.
For the reporter, could you go to the slide with the K calculation?
Extracting K?
Yes.
Here.
So, the mass is the same for all bands, right?
Yes. All rubber bands have this.
Okay, and the other two terms, you got both from the fit of the data, right?
Yes, we fitted the data, and we see that the line of the fit passes through the points. So this allows us to use the equations of the...
So you fitted the data with exponential and sine.
Yes, I fitted with this equation of the harmonic damped oscillation, and because it follows it, I can use the exact K.
And another short question: how did you ensure? First of all, did you ensure that the initial boiling temperature of the water was controlled in all experiments? And if yes, how did you do that?
I mean, it was boiled. I didn't, and the thing I tried to keep constant there is that the rubber bands were below the water level, so they were all.
Yes, but you put the rubber bands, all of them, in boiling water, right?
I did that, not all together, one per time.
The initial temperature of water was the same or different in your experiments?
When boiling.
Yes.
I didn't. I did not. I put the rubber bands after the water had started.
After you saw, you observed the water.
Yes.
Boiling.
After. Yes.
Okay. Just to confirm again, because when you were presenting, you said both theory and fit. So this is a fitted curve, right?
Yes. The fit is the theoretical, and the measurements are my experimental values.
Okay. Can you go to the slide that you have the 5 plots and the...
Okay, yes. The next one. Yes, this one.
So from each one of these, you extracted K from the fit? Is that
yes, from my... after I categorized the rubber bands and I got the rubbers that I wanted, 5 of them, I dedicated them into doing this in order to calculate the error. And then the rest, I used it for different... durations of boiling.
So you have 1 K value for each, and then you average them out to get what you show there?
Yes, I have 5 of them, and then with that I calculate the error that I showed in the last diagram.
Okay.
Can you change the... Lyceum, can you change the diagram to the last diagram? So these error bars are... this was made by the 5 not boiled rubber bands.
Okay. Can you go to your conclusions quickly?
Yes. No.
Okay. So you say Hooke's law is valid for rubber bands. What is your measure for testing the validity of Hooke's law?
The fact that Hooke's law is part of a harmonic damped oscillation, and since my rubber bands follow harmonic damped oscillation, then Hooke's law is applied.
Okay. And you say that at least at the beginning of the oscillation, is there some point in your results where you observed that your results violate Hooke's law?
Violate the?
Hooke's law.
No. I mean, each time, as you, in almost all the all the diagrams. Loiso, can you see that? In almost all of them, you can see that my values almost perfectly pass through the theoretical value.
Thank you.
We have been asked to just short the questions if there are nothing important. Let's get to the grading part. Thank you very much, people on the stage. Okay, keep it quiet in the room, please. Let's do the grading. Once again, the grades will be written and signed but not announced. And then we are supposed to have a very short break or no break, so make sure that you take a good rest between stages. We're going to start right away with stage number 3. Use this time to stretch a little bit, move around, and maybe, don't go far. Well, you can stand if you want. You can use this time as a short stretch. Don't go very far because we'll be starting right away. The reporter from the next stage could also start preparing, if you want to. Yeah, he has taken pictures of that already. You can write them down, sure. Exactly. Don't come in. Just okay. Yeah, just stretch.
Just stretch.
Okay.
I think stretching is always good.
Absolutely.
Like on the plane, you have to look at what people do on screen.
Exactly. Team Revolutionaries, if you have your reporter here, you could probably even start preparation. Yeah. All right, let's start getting back together here. And third reporter, the team of revolutionaries, has already started the preparation and they are practically ready to start. So let's get everybody back into the room, please. We are preparing to start, so let's get all the participants back in the room. And the jury also, please. Let's get back into the room, please. All the teams back to the room. All the jury members, please, back to the room. We are about to start, so please, everybody back to the room. The jury people, please, back to the room. Let's get everybody back to the room, please. Yes, we should be starting, so let's make sure that everybody is back to the room, please. Nobody listens, exactly. We'll have some social life right after the third stage. We'll make sure that it gets very social. All right, we have the jury back here, so we should be starting. Let's have the flight attendant prepared to operate the clock and have the reporter up on stage. You are ready to start, so let's start. Let's get the clock ready. And okay. Everybody is back in the room. We are ready to start, except for the clock. All right, you have 8 minutes.
Okay, so I'm Joanna. This is problem 2, mysterious precipitate. So the problem
Start the clock, please. Start the clock. Yes, go ahead, please.
Okay. The problem statement states saturated solutions of potassium nitrate, potassium sulfate, and iron 3 sulfate are prepared at 80 degrees Celsius. Equal volumes of these 3 solutions are mixed together and then cooled down to a certain temperature. How does the composition of the observed precipitate depend on the final temperature? So, what is a precipitate? In chemistry, a precipitate is an insoluble solid that forms within a liquid solution. But what does insoluble mean? A substance is described as insoluble when it cannot dissolve in a specific liquid, usually water. Go on, next. Okay, so the general reaction is that when we have a three soluble salts, then we create an insoluble salt, which is basically the precipitate. So basically, as a further explanation, three soluble salts dissolve in water and separate into their ions. So ions from the different salt come into contact and then join together. And if the resulting compound is insoluble, it forms a solid, and this is the precipitate, and we can see it in the photo there. So a salt's ability to dissolve is determined by the competition between the ionic bonds that we said that they dissolve when put in water within the solid, and the ability of water molecules to surround and stabilize the ions, because when the ions get into the water, they're surrounded by the water molecules. So if water molecules can pull the ions apart more effectively than the ions hold together themselves, the salt dissolves, obviously, separating into individual ions. And if the ionic bonds are stronger than the water's attraction, the salt remains solid, it does not dissolve, and that is what the precipitate is. So here, go back. Okay, so here we see how it dissolves into ions, and then as we explained here, it creates a precipitate if the salt remains solid. Okay, so in chemistry, a solid is an ionic compound formed from the reaction of an acid and a base, consisting of a positively charged ion, and from the base and a negatively charged ion from the acid, resulting in a neutral overall charge, like the table salt or other salts. So an acid is a substance that releases hydrogen ions when dissolved in water, and they have a pH below 7, and base is a substance that releases hydroxide ions when dissolved in water, and they have a pH above 7. So what happens with temperature? So most solids become more soluble as temperature increases. So the rate of solubility change differs for each compound. So the solid whose solubility drops the most may crystallize first, the precipitate, and in mixtures, the least soluble compound at the current temperature precipitates, even if it's a new solid. So basically, we're going to be testing these three salts. On the first salt, the solubility increases sharply with temperature. The second, the solubility increases slowly. And the third, the solubility increases and can form complexes in solutions. So salts containing the conjugate bases of weak acids dissolve more easily in acidic solutions because hydrogen reacts with the ions, shifting the equilibrium and increasing solubility. The equilibrium is basically the limit in which a mixture can be dissolved, and that's when the precipitate forms. So, for example, when potassium, sulfur, and iron sulfur become become more soluble in acid, while potassium nitrate is barely affected due to the strength of its acid, and the effect also depends on anion basicity. So more basic anions show a greater solubility increase, basically. So here are some parameters that affect the precipitate. We have temperature, concentration of the reactants, nature of the reactants, and pH of the solution. So again, how temperature changes and affects the solubility of liquids. This is because higher temperatures increase the kinetic energy of the solid molecules. So solid molecules are held together by intermolecular attractions, and the increased kinetic energy weakens the intermolecular attractions, making it easier for the solvent molecules to break up to solute molecules, causing them to dissolve more readily. So to predict which salt might precipitate, we first check solubility rules. So basically, nitrate's always soluble. So potassium nitrate will not precipitate. Potassium salts are always soluble. And then sulfate's usually soluble, except with these ones that we're not going to test. Okay, so when solutions of these ones that I mentioned earlier that we're going to test are mixed, they can form a double salt like this one. So this salt is variably soluble at lower temperatures. So potassium nitrate remains dissolved because nitrates are very soluble. So the mysterious precipitate is not from a simple ion exchange, but from crystallization of a hydrated double salt with a solution cools. So go on. So here is the hypothesis. So as temperature decreases, substances with higher temperature-dependent solubility, such as potassium nitrate, will begin to participate, changing the composition of the precipitate. So here are our parameters. We're basically just going to change the temperature of the solution and check the composition of the precipitate. Okay, so here's our experimental apparatus. Okay, so here's the procedure. We create 3 different saturated solutions, and then at 80 degrees Celsius, and then we combine all the saturated solutions, and we divide the mixture into 4 equal samples of 20 millimeters each. And then place each sample in a hot plate inside a larger beaker. So we can control the temperatures, so they can actually, and we monitor the samples for 10 hours so they can form the precipitate, and then we filter each sample, and in order to get the precipitate, we leave it to dry, and then we wash it with ethanol to remove any ions that might be still on the precipitate, and then we take 3 sub-samples from each precipitate and dissolve each 25 millimeters in order to test their composition. So here are 20, 40, and 60 degrees Celsius of the precipitates in the process. So here we have some reactants in which we used in order to check the composition of the precipitate from each sample that we collected. And each one basically checks whether there is nitrates. Okay, go on. Yeah, okay. So here we have a graph so you can understand, the table so you can understand it better. We have 3 samples of each temperature. We put the reactor in, and then we observe whether it turns the color that it should be, so we can see if there is iron, nitrate, or sulfur present in the precipitate. We did the same with 20 and 0 Celsius. And then here you just have like the color, so you can see that in 60 and 40 degrees, because we have higher temperatures, there is no nitrate. Okay, so we conclude that at 60 degrees and 40 degrees, we observe red color because of the reactant. So we see that iron is present. And then at 20 and 0 degrees, we see that everything is present, whereas in the 60 and 40 degrees, there is no brown ring from the reactant. So we see that no nitrate is present in the precipitate because we are at higher temperatures. Okay, so some possible errors would be cooling too quickly can produce small crystals that do not represent the true equilibrium composition. We might have an error with our thermometer, and we had inaccurate temperature control during cooling because of the thermometer and the hot plate that we used. Thank you.
Thank you. All right, questions from the opponent, clarifying questions from the opponent. Hold the timer, please, for the time being. All right, ready to start? Timer running.
Okay. Thank you for this excellent presentation. On the part you said you put the solids together. Do you mix them in a testing tube, or do you put them in testing tubes separately, or do you mix them together?
We mix them together in a beaker.
Okay,
so
thank you.
Okay.
Was the solution aquatic, or did you use something else?
Was the solution
aquatic?
It was water. It was liquid solution.
So aquatic.
Okay. Yes.
So what do you define as? Excuse me. No, that's wrong. Can you show me your experimental setup?
Yes. Show. That. Okay.
Okay. So you use the water bath.
Yes.
And are you aware that even if you use that to maintain the temperature, there could be variations?
We said there are possible errors. There could be some errors, but also we use the thermometer to check.
Thank you. And remind me quickly, you didn't have any graphs showing errors, right?
Showing the errors.
Yes.
No.
And did you have a method to find how you ensured your solutions were saturated? Just say yes or no,
yes,
not how you did that.
Yes.
Thank you. And when you mix the solutions, did you also use something to stir them together, or did you leave them as they were right there?
We stirred them together.
For how long?
Until there was a complete solution. It was homogeneous.
And did you use perhaps some kind of a machine, or did you use your hand?
Your hand until it was homogeneous.
Okay, thank you. And One final question. Do you know what's the pH range of a weak acid that you mentioned? There are some weak acids.
We have in our theory, if you want.
Yes. Do you have the pH range of that? Do you know that?
Yeah, we have in our theory. It's in the.
Can you show me that?
Yes. Wait. Go.
And while you do that,
I'll show it in the discussion.
In those bonds, that you had to mix together. Do you know if the intermolecular forces were strong?
I mean, we just know that they get weakened when we mix them together, so they can form the.
Okay, so you don't know quite whether they are stronger or less strong in a specific bond.
It's from the theory, but they get weak.
And so you maintained a temperature for 10 hours, you said, in the experiments?
Yes. We were there from the morning in the lab, and that's why we had them.
So you stayed in the lab in the entire time and checked it?
Yeah, we had the thermometer.
Okay,
and also it was the water bath.
That's very good. Thank you very much. And how did you do that exactly? Like, were you checking?
Short answer only, please. Very short.
Were you checking
answer.
the water bath?
We had the thermometer, and we had the water bath at the certain, also
Thank
the
you.
20 and 0.
Okay, thank you.
I'm going to tell you.
Thank you. I have to cut you off. Thank you. All right, preparation time of the opponent, please. Quiet, please. Timer for the preparation time. Thanks. Okay, we're short of preparation time. Let's make sure that everything works. Hold on, yeah. Yeah, you can prepare for the next stage, but we'll not start the timer yet until she gets back on stage.
May
All
I
right,
begin?
statement of the opponent.
Okay, so this is my presentation. So we have saturated solutions of potassium nitrate, potassium sulfate, and ferric sulfate prepared at 80 degrees Celsius. So we will skip over that. We're familiar with the problem statement. This is an overview of the report. It was pretty good, we believe. There are some areas for improvement, however. So on the theory, they explained solubility and crystal formation. The theory describes really well what a precipitate is. They explain why each parameter affects the results. They include molecular structures, and they have visuals both regarding theory and their experiments. Now, they did not explain what ionic bonds are. They did not explain key terms of the problem as what is a saturated solution or how they create a saturated solution. They didn't have an explanation of the cooling rate, of the filtration, and they had a poor time management, so the results were presented to us in a pretty rushed way. They had tables organizing the results. They used a water bath to minimize temperature variations. However, there were no error bars. There were no visuals for the experimental procedure and the results. There was no quantitative analysis of the final composition, only qualitative analysis on the colors. There was no RGB analysis for the change of the colors, and the temperature variations using a water bath were not controlled accurately. Finally, we suggest that you explain better the key terms of the theory and that you just spend some less time on analysis of the theory so that you have more time to analyze the result. This was a pretty rushed way to present a problem, and we did have an issue with that. And finally, you should have used more visuals of the result and try to do a quantitative analysis instead of a qualitative one. We really had a problem with that. We wanted to see perhaps the amount of the precipitate in grams in some way, how that was calculated. Yes, and that was all. Thank you.
Thank you very much. All right. Questions from the reviewer? To both the reporter and the opponent. Please, opponent, get back to... Oh, that we have a discussion first, of course. And let's have an interesting discussion.
Okay, so I have
5 minutes for the discussion.
Great, I have
now.
some questions for you before you start. I mean, you mentioned error bars. Where exactly did you want to see error bars in my
Yes,
experiment?
I wanted to see an error bar. You included possible errors, but you didn't use error bars.
Okay, but I didn't use any graphs in where I could put error bars. I just had tables.
Yes, but you should have included them so that we could see
what's graphs or error bars.
Something that has an error bar that shows us the possible error. What's the percentage
also
of the
graphs
possible
for
error?
me. Okay, what graph exactly did you
so
want me to...
I also wanted to ask...
Okay, ask me.
It says that you prepared a saturated solution.
Okay, I'm gonna explain.
How did you do that?
Okay, I'm gonna explain to you now. Basically, we just added salt until salt wasn't dissolving anymore, and that's the saturated solution.
I don't think that's a pretty accurate way.
Okay,
a more
what did you
accurate
wanna
way
do?
to do that was to create an oversaturated solution and then filtrate it so that you have a saturated solution exactly.
Okay, we didn't do that, but I think what we did was pretty accurate as well.
Did you include that in your possible errors, however?
No, we didn't. We could have. Okay.
Right. Thank you.
Also, you mentioned something about RGB analysis. What did you want to see? I mean, the precipitation, how it changed colors.
Yes, kind of that. You could use the RGB scale to describe this change.
But the change was very, I mean, it was very distinct.
That's a qualitative result. You can't really tell if the change was distinct.
But we didn't want a quantitative result either.
I mean, a quantitative result would be more objective and not so subjective.
And also, how would I use a quantitative result? I mean, so the percent that
using
it
the RGB scale, you could do that on Python, and yeah.
Sure. Okay.
And yes, you generally had no quantitative analysis. I don't understand why that happened.
Because this is a qualitative experiment.
How is it a qualitative experiment? I already proposed some ways that you could make it quantitative.
Okay, sure. Also, you mentioned about the theory that I lacked cooling. I have it, I just didn't have time to explain. Did you want me to explain it now, or are you good?
Just something really short on that.
Okay, go to the slide. Before? Okay, good. Do you want something for me to explain?
No, thank you.
Okay.
And what other solution would you use to create? What other solution would you use to create?
I mean, we use
a solution like instead of an aquatic one. What else could you use?
I mean, we use an aquatic one because that way we can see the.
What else would you use, and how would those results differ if you used something else?
I didn't use another way to do it, so I cannot give you.
Did you not research another way to?
No, I did
how
not
you
because
did that.
I didn't have an intention to do it another way. I want to do an aquatic solution.
So
that's what I did.
if you used something else, which had, for example, which was like kind of acidic, what do you think the results would be how would the results differ in the experiment?
Well, we did not test that, but I assume because the pH would be different, then that would affect the results. I cannot give you a very clear answer.
Is this an assumption that you made on your personal opinion, or is that based on the theory?
I'm telling you, I did not conduct based on the theory because for the pH, I did not conduct that experiment, and I cannot give you.
Can you go to the results when you had this table with green and red? Yes.
Okay. Do you want me to explain what that is?
Yes. What is that red?
Okay. So basically, we used some reactors to basically show if the precipitate will change color.
Also, why is half of the bond missing? I don't see potassium here, and here I don't see
let me tell you.
Okay.
Because basically we want to test if iron solves something.
So you're out of problem statement. You used separate things.
No. This is just the ions of the salts that we used, and we wanted to see if these were present in the precipitate. That's what
they would obviously
composition.
be. You showed us cans of those chemical bonds and combinations. How would they not be present in the experiment?
Because we mixed. We mixed the solutions together. So then, and then we separated.
But these don't disappear if you put them.
Let me explain it to you. And then we separated them, and then we want to see the composition of each one in different temperatures. We know that the solution was the same, but we want to see if when one of these would show up in different temperatures. That's what we did in our experiment. That's the composition.
So you're assuming, so does it say that nitrate disappeared in 60 and 40 degrees?
It just didn't, it wasn't in the precipitate.
Finish your statement.
I
All right.
understand. Thank you.
Thank you very much. And this is the end of the discussion. Have a good round of applause. And the reviewer comes to the stage. Keep it quiet, please. Clarifying questions to both of the discutants from the previous stage. Quiet, please.
Okay, so...
Quiet, please. Timer starting.
Towards the reporter, do you think that because you heated the water and not in a hydrocollator, then you're out of problem statement because the temperature actually dropped and it wasn't in 80 degrees Celsius?
You mean the first solution that we did, the mixed one?
Yes.
We had it at 80 degrees Celsius, and then we...
How did you have it in 80 degrees?
In a water bath, and then we had a thermometer to control that.
So it was all the time 80 degrees?
No, then we split the solutions, and then we want to test how the precipitate would be composed in different temperatures. That's why we limited the temperature.
Do you agree that she's out of problem statement since she's not in 80 degrees?
Yes, I totally do agree. If that wasn't prepared at 80 degrees Celsius, just like the problem statement says, then they are out of problem statement, and this entire report is wrong.
Okay, and towards the reporter, how did you identify the composition of this?
I'm sorry, wait a second. The problem statement says cool down to a certain temperature.
But it says that they are prepared in 80 degrees.
Yeah, they were prepared in 80 degrees.
How were they prepared in 80 degrees if you just heated it and then let it just... The temperature drops if you don't heat it constantly. So,
what do you mean? But once we split the solutions, then we obviously had to cool it down.
Okay.
I don't know.
How you said that you didn't utilize RGB or hex colors. So how did you identify the colors?
We saw a change, and the change was very distinct. So we didn't.
So based on your site.
Yeah, we didn't. Because we didn't see that there was a very slight change. So that's why we had to use the color analysis. And also, RGB analysis is irrelevant because we don't really focus on. No. Nothing. Yeah, but if it's relevant, then how would you identify?
No, it's not
it?
no, I'm telling you, we saw it because it was the color change was very distinct, so we didn't see the use of an RGB in this case.
Okay. And do you agree that solubility is temperature dependent? I mean, it depends.
Yes, that's our whole
Very short
experiment.
answer, please. Okay, thank you. All right, this is the end of the clarifying session, and now we have a preparation time for the reviewer. Please hold quiet in the room, please. Quiet, please. Yes, preparation time. Good idea. Quiet, please. I know that everybody is excited. Let's give them a last chance to have a good preparation. Quiet, please. Quiet. Silence, please. Quiet, please. Thank you. All right. Kiveli Nikolai. This is the end of the preparation time. Are you ready to start? Go ahead.
Okay,
Timer starting.
I am Kiveli, and I will be presenting the reviewing for problem 2. So for the report, there were some merits. She had theoretical insight to the definition of the precipitate, as well as the acid and the base. She had insights about how reactions occur. Then she had good experimental setup. She used visual demonstration of the apparatus that she used, and she controlled the water bath temperature. However, there were multiple areas for improvement. She had limited theoretical insight to the precipitate as insoluble in many conditions, how saturation affects crystallization, the KSP and the Q values, which are, of course, relevant to the whole experiment. She missed parameters. She was out of the problem statement. They did not use a hydrocollector, so the water temperature would change significantly. Then she had poor experimental control. The colors were only qualitatively analyzed by eye and not with RGB values. Then for the opponent, she correctly pointed out that there would be variations in temperatures in the bathtub saturated solutions not explained in theory, and that there was no visual demonstration of the experimental procedure nor the RGB analysis. Then she had some trivial points about the insufficient theoretical model, invalid points about the filtering over such supersaturated solution, and she missed that the solutions in the apparatus seemed to be supersaturated and not saturated, as the reporter mentioned. Then for the discussion, the opponent thinks that it is not correct, that this is not the correct way to make a saturated solution, and they also believe that they should make a supersaturated solution and then filter it. The reporter said that she had just to add salt to make a saturated solution. We agree with the reporter because a saturated solution forms pure crystals, supersaturated forms mixed crystals. The solution in the apparatus appears supersaturated. Then for the RGB analysis, of course, we agree with the opponent that there should be an RGB or even hex code analysis. Then for the errors, the opponent said that they should have an error bar to present their errors, while the reporter mentioned that there were no graphs to use these error bars. In our opinion, if there were graphs, the error bars would be necessary. However, they did not present any graph, even though they could.
And then for the nature of the experiment, the opponent said that it could be a quantitative experiment, while the reporter mentioned that it should be a qualitative experiment. Of course, we agree with the opponent because quantitative analysis with RGB would limit human eyesight error and make more accurate conclusions. Thank you.
Thank you. Lovely. Now some final words from the opponent first. One-minute timer.
Okay, so we would like to thank both the opponents and the reviewers for this very good round. What we have to say is that we agree that with the reviewers that color is actually a highly subjective parameter, and it differs from person to person. So a scale would be really important. And finally, we also wanted to answer to the viewer's point regarding our method of finding a saturated solution. This is how chemists do it in real life labs. It is not an invalid method. And we would like to say that we would like to have a quantitative analysis so that there could be error bars and graphs. We would really like to see an expected error from this experiment. Thank you very much.
Thank you. And some final words from the reporter.
Thank you all for this fruitful debate. First of all, for the reviewer's point that we said that precipitate are installable, we agree. We had it on the theory, but we didn't mention it because it was wrong. We shouldn't have put it there. We just skipped it over. I don't know why you said that we were out of problem statement because we didn't use a hydrocollator. A hydrocollator is a water bath, and we kept the temperature constant because at 80 degrees all solutions were saturated. So then when the temperature drops, that's when the precipitate formed. And also about the RGB discussion, I mean, yes, we could have used an RGB in order to have more objective results about the color analysis, but we think that because the color was so distinct, I mean, it was either a dark red or like a brown circle, then we didn't do that. So thank you for the recommendation, but yeah, that's it. Thank you.
Thank you. All right, big round. Football. Oh, well, the teams are done. Now let's get the jury working. Questions from the jury?
Okay. Thank you guys for your fight. I have some questions.
Does this work? I'm sorry for interrupting. I just had an issue with the microphone earlier, so I'm making sure this works.
Okay, great. I'm going to start with the opponent. First of all, you repeatedly asked for quantitative results. I mean, it's an inherently qualitative request from the problem statement. So what kind of quantitative results would be productive in this experiment?
Well, since they experimented parameters like color chains, we would really like to have something like an RGB scale. I mentioned that many times. Color is highly subjective and differs from people to people. Also, we would like to see a measurement of the mass of the solution before divided by the mass.
Thank you.
The mass after.
Regarding that, because the reviewer mentioned it also, could you explain how an RGB value measurement could also be useful in this experiment?
Yes, so basically they didn't use an RGB color measurement. If they did, or even hex color coding, then they would be more objective, because if I identify a color as blue, for instance, another person might identify it as green, so it's not objective.
Okay, thank you. And one short answer on what did you mean when they said they had some missing K and Q values regarding the hydrocollator?
Okay, so Q values are basically the ion product, and the KSP is like the solubility product It's a constant for its temperature, of course. And it depends because if the Q value is equal to the KSP value, then we have equilibrium. But if KSP is bigger than the Q value, then the solution is unsaturated, and vice versa, it will be supersaturated. That's why it's connected.
Okay, yeah, question to the reporter. So, can you elaborate on your first possible error about small crystals forming, and how does that affect the experiment?
Basically, we took the precipitate in the filter. We also used ethanol in order to get rid of any ions, because if there were ions left from the solution, then there would be crystals that would actually affect the precipitate, and it wouldn't be from the same. The solution wouldn't be from the same precipitate. Yes, I mean the ions would form the crystals, and it wouldn't be from the same precipitate if it changed colors.
Okay, thank you.
Can you please go to the cooling rate slide? So, when you have either slow cooling or fast cooling, do you get a precipitate in both cases, or is it a precipitate in both cases?
I can't hear you.
Sorry. Okay. Do you get a precipitate both with slow cooling and fast cooling?
Yes.
Okay.
I mean, slow cooling just gets like a well-formed crystals, like it gets more crystallized. But again, it's the same thing because precipitation could also be crystallization.
Okay.
Thank you for your presentations. We'd just like to deepen your comments on each other. So, reporter, how do you react on saturated and oversaturated points which were raised? And then for the reviewer, how would you react on the hydrocollator being said about water bath that has been used?
You mean what we would...
So they've mentioned the difference between saturated and oversaturated, and results wouldn't be the same. So what is your comment?
I mean, I don't understand the question.
So they indicated that there should be a difference between saturated and oversaturated solution.
Okay.
So what is your comment on that?
I mean, we didn't explore oversaturated solutions because we made sure that they were just saturated. But I mean, when there are oversaturated solutions, even at 80 degrees Celsius, that means that the precipitate wouldn't be as clear because there would be some salt that wouldn't have been dissolved, so it wouldn't form the precipitate.
That's okay. You can always say, we didn't do that route.
We didn't do it.
Okay.
No, we didn't do it.
Because it's a very big area, and you do it in 8 minutes, so you've done it really well.
Okay.
And then for the reviewer, the name for the water bath, is it something that they used or didn't use? Thank you.
So I highlighted that they should use a hydrocollator, but during the clarifying questions, she mentioned that they didn't use it. But then in the final speech, she said that she did, so that's why it's confusing. So what's your question exactly?
Other questions in the back? No? All right. All right. Well, thank you very much once again. And now let's get the jury working hard on the last evaluations. We're practically done. Let's keep it quiet in the room so that the jury can do their job well.
Ωραία, τελείωσε ο διαγωνισμός. Περιμένουμε τις τελευταίες βαθμολογίες για το τρίτο stage. Η αλήθεια είναι ότι δεν πολύ είδα το διαγωνισμό. Καταλαβαίνω ότι κάποιος πρέπει να είναι πίσω και να βγάζει τις βαθμολογίες για να είμαστε έτοιμοι. Mr. Matev, when you are ready, give to Christos the grades. Christos, you know what you do to do. Λοιπόν, μέχρι να ετοιμαστούμε για την τελετή λήξης και απονομής των βραβείων, θα έχουμε την τιμή να έχουμε εδώ μαζί μας μία κυρία από ένα πανεπιστήμιο της Κίνας, το West Lake University, το οποίο βρίσκεται σε μια πόλη, μικρή πόλη, 12 εκατομμυρίων, κοντά στη Σαγκάη, στην πόλη, αν τη λέω καλά, Χαντσού. Μίνγε. Χαντσού. Ωραία. Η κυρία Μίνγε θα μας κάνει λίγο μια παρουσίαση, καθώς έχουμε ξεκινήσει μια συνεργασία με το πανεπιστήμιό τους, και θα μας κάνει μια σύντομη παρουσίαση για κάποια προγράμματα που προσφέρουν τόσο για προπτυχιακές σπουδές όσο και μεταπτυχιακές, αλλά και summer schools.
So until we're ready to begin with the closing ceremony, we have here a representative from Westlake University that started a project basically with the Hellenic Physical Society, and she will present some summer programs, and she will talk about her university and things that us students can do with the university. So whenever you're ready.
everyone. Thank you for your patience. Thank you. Yeah. Again, my name is Beverly. I come from Westlake University from China. First of all, I want to extend my gratitude for Hellenic Physical Society to invite me to join this wonderful event. And during the 3 days here, well, this is my first time being in Greece, and I'm so impressed by your passion in science and engineering. And I'm so proud of you guys. You are all the winners in my heart. So please give yourself another round of applause. Congratulations, no matter what the results are. So this is why we're here to collaborate with the society, the Physical Society. So Westlake University is a science and engineering university, very strong in cutting-edge research. We are located in the beautiful city of Hangzhou in China. So probably these days you have passed my table outside and learned a little bit about Westlake. But today we're going to give you a more detailed introduction. So before I go further, we're going to watch a video about the pre-college summer program that I've been talking to you the 3 days. So this is what happened in 2025. No sound. So basically, before we have any sound, this is what we happen. We always had 16 days at Westlake. We invite about 50 students all over the world who are passionate about science and engineering to Westlake for this program. We have 4 different tracks: physics, biology, mechanical engineering, and biomedical engineering. So for you guys, it's a great opportunity to learn from our professor and then have a real hands-on experience. So biology, the topic's gene editing. Chemistry, it's nanosynthesis. Physics, it's about the topology. You know more about physics than I do. Mechanical engineering, that's building a robotic fish that can go underwater to do water research. Last but not least, biomedical engineering. So that's a very unique cross-disciplinary program that combines medicine, biology, and engineering. So you are going to learn how to replace damaged body tissue, for example, liver or hearts, which is very meaningful in medicine. So these 16 days will change a lot of people's, maybe the life or future, will change their mindset about what they're going to do in the future. Every day in the morning, you are going to work in the labs for 3 hours from 9 a.m. to 12
aliens are real, so I thought addressing that questions in a
So yeah, let's keep
scientific
watching.
way was very interesting.
It's a technical opportunity for someone who wouldn't really travel too much to go to China, like one of the most innovative places and a future leader in tech, and just study with like-minded peers and really get ahead over summer. I mean, it's been fab.
That's so much more advanced than where I come from, and just the facilities themselves are state-of-the-art, top-notch, and I think that anybody who wants to be able to go forward in innovation should come to this university because it's so advanced.
Honestly, it was nothing like what I expected. Like walking into the lab on the first day was just kind of like shocking, but a good shock.
Well, in the lab, we worked on suppressing the green fluorescent protein, also known as GFP.
I'm working with nanoparticles, so I've been able to synthesize and manipulate a bit of nanoparticles. And it's just been like really fun.
Sure, so in our mechanical engineering lab, we've been building little robotic fish. So we're given some 3D printed parts, and we're doing some electronics and coding sort of stuff to make that work.
In terms of research, we've been creating like nano stir bars out of gold particles, which is something I thought was incredibly cool.
Yeah, full technical dinner time conversations, that's quite rare. It's quite a nice opportunity.
We all have, everyone going into a STEM field will have to deal with research, and I think getting that exposure early and also being in that environment allows us to not be overwhelmed later on in our career.
For me, Guangzhou
really has felt like home in many ways, which I was not expecting it to feel like.
The nature has been really pretty. Like I've never seen lilies, like the water lily flowers before.
Westlake itself is beautiful, so yeah, definitely a good place to go to visit.
I wasn't expecting it to be as industrialized as it was compared to the U.S. where I live. It's pretty.
I was able to see such a variety of places, even within a small area.
You could go on the street and you see a skyscraper and you see a traditional Chinese house right next to it, which was also quite a shock for me.
Specifically, it's like doesn't get as much attention from like the international world as like Beijing or Shanghai would, but it's still has a lot of history and culture. And
is a city that blends historic and modern things.
We have a lot of skyscrapers and stuff, but here it's way more. It actually shocked me a little bit, but it's really cool and I love it.
It's unbelievably stunning. It's so well planned. Like the infrastructure is crazy. It just seems a tech hub. It seems a hub of innovation.
I think I could not have imagined my life without coming to this program.
So this is a video about the 2025. We've run that program for 3 years now, and it's huge success. And in the past, we invited about 50 talented students all over the world. They are high school 10th graders or 11th graders. So most of the students in the past were from the United States, UK, and this is my first time coming to Greece. I'm so excited that possibility that we can invite a few students from Greece to attend the Westlake University program. Actually, 2026 programs or the admissions are already over, as I talked to a few of you during the 3 days. But since we're in collaboration with the Hellenic Physical Society, I want to reserve 2 spots for the students present today. So if you are still interested in the program, please apply before April 15. While other people are already working on their visa and passport and the travel documents, we can reserve 2 spots for you to attend this year. As long as you are current 10th graders or 11th graders, you are eligible to apply. If you are younger than that, you can certainly apply for the future program. And then every year, the program will be open since September all the way to the February the next year. So we kind of open the application very early. Outside the auditorium, there's a desk, Westlake. We have brochures there. So before you leave today, please grab a brochure and my business card and reach out to me if you have any question. The whole program, we only charge $750. That's about 700 euros in total. We literally covers everything else, like international airfare. We buy you the ticket. We fly you over from Greece to China. We pay the few trips to Hangzhou and Shanghai. We also cover all the program fees. So 700-ish euro is the only payment you're going to pay. A lot of people describe it's an opportunity too good to be true. And I agree. So students, parents, and teachers, please consider this opportunity. And for the question, you can reach out to me. So thank you. This is the QR code. Students, if you are interested in attending this year, 2026, and you are currently 10th or 11th graders, please scan this QR code and finish the application before April 15. So application form needs your basic information, a few essay questions, and a video question. So submit it before April 15, and we're going to process your application. Next slide. If you are younger students, join our mailing list by scanning this QR code, so you will receive further information about the future program. And Westlake also offer undergraduate program, which if I have time, I'm going to talk about briefly. We also offer summer research internships of undergraduate level. So our judges or maybe other students who are interested when you go to college, you can certainly stay connected with Westlake or a PhD program. So now a little bit about Westlake. We are located in the beautiful city of Hangzhou. We are very unique. First, research-oriented. We're doing the cutting-edge research. We are going to educate the best scientists and engineers in the world. And we are very, very top, and we're doing the best in these fields. We have the School of Life Sciences, School of Engineering, School of Science, and the School of Medicine. So we only have these fields, but we are pushing ourselves to the best. We have 2 modern campuses. So this is kind of the map where we are. We are just 1 hour away from Shanghai. Maybe you haven't heard about Hangzhou, but definitely you heard about Shanghai, which is a great, great city. 24 million people, the population. And they have Disneyland, Disney World. They have a lot of fashion show, museum. So 1 hour away from Shanghai, you're going to have all the resources just by hand. We have 2 campuses. This is where we place all the undergraduate students and summer program students. This is very modern. We're 7 years old, and this campus is only 3 years old. Now, a pop quiz. Question: what does the shape of the campus look like? A circle. What does a circle look like to you? All right, this is use some biology knowledge. Any idea? What does it look like? That's a very good interpretation. I'm going to add it to our answer list. Anything else? An eye, yes. Like the evil eye in a Greece culture. What else? Yeah. Who says cell? Oh my God. Cell, yes. You have the other answers? Yeah, cell is our favorite answer. So cell is important to any kind of life, and this part of building is the most important of Westlake. This is what we call the academic ring, because we connect all the 4 schools with one single structure. We highly value interdisciplinary education. We want people from different subjects to see each other in the hallway and to talk and to collaborate. So this is academic ring, this is the cell. And that at the corner here, we have undergraduate dorms, which is very comfortable. So if you come to Westlake, you're going to have your single bedroom. Everyone has single bedroom. You have the absolute control to the AC. For the summer program, you're also going to live there. Next slide, please. So Westlake is very small. We're small, but we have big dream. So this is our full capacity in a few years. We have more PhD than undergrads, but we are going slowly, and we're going to do our best. Next slide. We recruit faculty from all over the world. We don't recruit from China because we are trying to promote a more international environment. These professors really understand how to teach and doing research in an international environment. So just a quick example, you can go to our website to see their research directions. And one important feature at Westlake is we really allow every student to start research very, very early, from day 1. So in other universities, you probably can start to do lab work in the 3rd or 4th year, or maybe even until you get a PhD training. However, at Westlake, we're going to give you an academic advisor from day 1. You probably can have 2 from different subjects. And that way, you're going to receive systematic research training, and you're going to maybe publish your own paper, get involved in PhD team very early. So this research is not for everyone, but I guess it's for you here today, everyone. So these are our undergraduate majors. We have limited but very strong majors in science and engineering. I'm not going to talk too details about it. You can have a brochure outside. I have those on the table. Overall, the first 2 years is general education. You decide the major at the end of the 2nd year. In the 3rd year, we're sending everyone to study abroad for 1 semester. So these are our partnership universities. You can tell how strong we are globally. We're in partners with UC Berkeley in the United States, Rice University, or you can go to Canada, Australia, or Sweden, or Singapore. The world is there for you to explore. So you go to China, you are studying abroad, then we send you to study abroad again, like abroad, double abroad. So I certainly welcome you, everyone, to just visit Westlake and study there. Mandarin. So we don't teach in Mandarin. It's an international environment. We teach everything in English. However, since you're in China, we're going to teach you Mandarin for up to 4 years. You'll be able to speak to 1.4 billion people on this planet, which will give you a lot of opportunities. Mandarin will be an important skill for your future, no matter where you are. Residential colleges, so we have 4 of them. This is just a quick look at inside of the room. So this is your bedroom, guys. Bring your own teddy bear though. This is our decoration. You share the living room and bathroom with 3 other students. It's very, very comfortable. So for the undergraduate students, guess how much it costs? I've already surprised a few of you. So the annual cost of the housing is about $300 US. It's less than 300 euros a year. So this is your room for the entire year with less than 300 euros. We provide a well-rounded support system for every single student because we are a small university and you're going to know each other, build a deep connection with the professor and the staff. We have absolutely modern facilities. So China is a developing country and develops so fast. We have everything new. It's like a small town on campus. Salon, hair salon. For guys' haircut, it's only 20 yuan, which is like a 2-3 euros for a very nice haircut. So the living cost in China is absolutely affordable, and we provide a high-quality education. And we provide a vibrant community on campus. We have a lot of student clubs, soccer, tennis, or a K-pop dancing club, a lot of them. And we also have a good academic environment, like globally. We invite the Nobel laureates to give us talks and have lunch with our students, etc. Living in Hangzhou. Does anyone here use DeepSeek? Yeah, someone use DeepSeek AI. Does anyone hear about Alibaba? Alibaba? So Jack Ma used to be one of the richest, you know Alibaba. Used to be the richest guy in China. So these technology giants are based in Hangzhou. Hangzhou is a very vibrant city, full of opportunities. So if you want to learn about the future of China, the technology, you go to Hangzhou. And this is where the future is. I'm going to go quick. So we provide a generous scholarship to everyone. So as long as you get admitted, don't worry about the tuition because we're going to give you the best support we can. We don't want the money to be in your way. So for the 2026, if you are still considering college for the upcoming fall, you can come talk to me. We're still taking applications. Now, well, basically, that covers everything. So again, summer program would be the first step to a lot of you. It's like a test drive. And also, in collaboration with the Hellenic Physical Society, we certainly welcome you to join the China trip in the future. If any high school students are interested in coming to China this summer, come talk to Apostolos. So yeah, that's wrapping up my presentation. Thank you very much, and congratulations.
Thank you very much. Thank you. Ωραία. Nada, if you need 2 minutes, no more. 2 minutes. 2 minutes, come. Just 2 minutes. No PowerPoint. 2 minutes or nothing. Come.
I don't know.
2 minutes, yeah? I'm going to look at the time. So thank you for this time. The time I wanted to use that we all learn from a Greek history, philosophy, and science. So I'm trying to tell to Apostolos, we should take this opportunity to be in this Apostolaki. So Apostolaki Mu gave me a few minutes to tell you how great history and philosophy of this country is. So I'm just giving you a short flavor because I don't want anybody to come here again and not leave with a paper of 20 words that you see around you that you can understand. I'm sure you could see pharmacy, pharmakeia. And I, last couple of days, was going in the morning and taking pictures of the words that I recognize. And I was learning what Greece has given to all of us and how it has changed with centuries. So we are just going to give you a very, very, very quick flavor. And I really expect that each of you next year, In order to leave, I'm going to be at the door and you have to give me a paper with 10 words that you noticed. Because you all speak a little bit of Greek. So, does anybody know any word which comes from Greek? Greeks don't speak any other people. Do you know any concept in science? Yes. But not Greek people. Yes, go. Very good. That's one example we have here. Biology. Now, Greek person, who can tell us what bio is? In Greek? Life. Bios, life. So biology is the science of life, and they all know that. Now, in France, we use the word bio to say organic food. So you have organic apples, les pommes bio. I mean, apples which are live. How do we know? So did you manage to charge it? Did you put it just under the last one? Are you going to link it? So, does anybody have a USB key quick? USB key, okay. Because I just want to show you quickly with the USB key. Because without showing it, there's no point. Sorry. We can't show it? Okay, we can't show it, and I'm going to tell you. The word physics comes from nature. So when you say something is natural, that means it can't be in any other way. The word eugenics, it may be used in a different way, means good, and genetics, the way how you are born. And empathy comes again from Greek, and maybe you can tell us what empathy is. We can't project it.
No, they can. Okay. So basically, empathy is the only word that does not have a complete translation in Greek. It is derived from a German concept that originated in the 1870s. No. And basically it's and pathos, so it usually means putting yourself in someone else's shoes, feeling what they feel in English.
Anybody else want to give one example? Now, I did take all these photos last 3 days.
Adam's
Never mind
yours.
technicalities. We just do it with it. Anybody else want to give one example? We finish with that. Want to give the example? Of course, there is milli, micro, nano, pico, hydro, atom, and everything you think about. So keep your eyes peeled to all the signs you can find in Greece. And Greece, thank you for leaving a long-lasting legacy to the rest of the world. Evharisto.
Thank you very much, Nada. But εδώ μαζί μου στη σκηνή έχω ένα λίγο πιο a more important person than you. Την Ηλέκτρα. Ηλέκτρα, ποια ομάδα νομίζεις ότι θα κερδίσει? Γεια σου, Ηλέκτρα.
Γεια σας.
Ποια ομάδα πιστεύεις? Ποια ομάδα νομίζεις ότι θα κερδίσει?
Δεν ξέρω. Όλες οι ομάδες ήταν πολύ καλές και μου άρεσαν πάρα πολύ.
Και εμένα μου άρεσαν πολύ όλες οι ομάδες. Αλλά πάντα κάποιος είναι λίγο καλύτερος από τους άλλους. Έχει σημασία?
Όχι, σημασία έχει το παιχνίδι.
Πολύ σωστά. Ξέρεις τι άκουσα πρόσφατα και μου άρεσε πάρα πολύ?
Τι?
Η ερώτηση λέει, τι διαφορά έχει η πρώτη από την τελευταία θέση? Ξέρεις?
Όχι.
Η πρώτη θέση είναι μια τελευταία θέση που δεν σταμάτησε να προσπαθεί. Άρα θα προσπαθούμε?
Ναι.
Λοιπόν, να ξεκινήσουμε με την τελετή λήξης. Πριν ξεκινήσουμε και μέχρι να είμαστε πλήρως έτοιμοι, χρωστάμε ένα πολύ όμορφο βίντεο από το σχολείο Heritage που ήρθαν από την Κύπρο. Οπότε, Ζάχα, μπορείς να το πατήσεις κάπως να παίξεις το βιντεάκι? Έλα, Ηλέκτρα, από εδώ μαζί μου. Εκεί με την τοντό. Πάτα το play. Τώρα δεν ξέρω αν θα έχουμε τον ήχο.
On a small piece of
named the Heritage Private School. Welcome. Welcome to the most prestige school in Cyprus that is giving excellent education since 1987. But now let's meet the teams.
We are Naturalists! We are VSOC team! We are technically bonded!
Throughout our experiments, we had many success and many fails, which is normal. Everything was part of the journey. This is our national dish called souvlaki. This dish contains grilled meat with pita, bread, and with many different vegetables, and with a Greek sauce called tzatziki. Thank you everyone for watching, and we wish everyone a good luck.
Τους ευχαριστούμε πάρα πολύ εδώ για τη συμμετοχή τους. Λοιπόν, απλά βάλε εκείνο που ήταν η προηγούμενη καρτέλα. Εκεί, ναι, εκεί. Ωραία, κάτω full screen. Control F5. Ναι. Να έρθω. Άστο σε μένα. Πάτα escape, πάτα escape. Κάνω εγώ, άστο, ευχαριστώ. Λοιπόν, θα ξεκινήσουμε πρώτα με το να πούμε ένα μεγάλο ευχαριστώ στους ανθρώπους που αν δεν αφιέρωναν αυτό το τριήμερο που είναι οι μέρες αργίας και οι μέρες να περάσουμε με την οικογένειά μας, δεν θα γινόταν τίποτα από όλα αυτά. Αυτοί οι άνθρωποι αφιέρωσαν πάρα πολύ χρόνο, με πολύ όρεξη και αγάπη για όλα τα παιδιά, για να τους βοηθήσουν να πάρουν μέρος στο διαγωνισμό. Είναι όλοι οι κριτές μας, οι team leaders, όλοι οι βοηθοί, όσοι χρειάστηκαν τέλος πάντων εδώ για να γίνει αυτός ο διαγωνισμός. Ένα μεγάλο χειροκρότημα, λέω ονόματα και θέλω να έρθετε όλοι ταυτόχρονα στη σκηνή. Αμυρίδου Βικτωρία, Ανδρέου Νάταλη, Αποστολίδης Δημήτρης, Χατζησημεωνίδου Τζο, Χριστοδούλου Βικτωρία, Κέρτης Κλέρ, Δάκου Έμι, Διαμαντόπουλος Ζήσης. Ανεβείτε παρακαλώ όλοι στη σκηνή. Διβέρης Οδυσσέας, Ευσταθίου Άννα, Γκρίτζαλη Μαρία, Γκιαβίρα Μαρή Γκορέτη, Χουάνγκ Γιουκάη Ματέο, Καϊμάκης Αλέξανδρος, Καλαϊτζή Ντοντό, Θεοδώρα, Καλατζής Ιωάννης, Καλούδης Φίλιππος Ακύλας, Κανακάρη Χριστίνα, Καπρούλια Σωτήρης, Καρελή Αργυρό, Κιγμίκη Ζαχαρούλα, μην μπαίνετε μπροστά δεν βλέπω. Κιωσέ Γρηγορία, Κωνσταντινίδης Γιώργος, Κοροπούλης Βαγγέλης, Κοτσίδη Μαρία, Κουβουτσάκη Τίνα, Λαμπόκ Ρέιτσελ Κυρόντι Αγιώτ, Μάσα Κέβιν Ντεσιρέ, Μάτας Νάντα, Μάτεφ Λαντέν, Μπαζίρα Φρέντ, Μιχελής Δημήτρης, Μικελίδης Θεόδωρος, ελάτε στη σκηνή όλοι. Νικολαίδου Αλεξάνδρα, Νακίτο Μαρία Ούρσολα, Οικονομίδης Γιώργος, ο Λούκα Τζούλιους, Πανταζόπουλος Θανάσης, Πετρογιάννη Κωνσταντίνα, όλοι στη σκηνή. Ραμιζάνοβα Άιζα, Τερψιάδου Μυρτώ, Τουλάκης Χρήστος, Τούλης Δημήτρης, Σακμάκης Γιώργος, come to the stage guys, in front. Τσαβδάρογλου Ελένη, Τσίκος Βασίλης, Τσιτσάτζε Ρόπικο, Τσολακίδη Φέντρα. Ηλέκτρα, ξεκινά να τους μοιράζεις από ένα, από εδώ. Από εδώ ξεκινά, ναι τώρα, μοίραζε. Τσολακίδη Φέντρα Μαρία, Τσιτσάτζε Ρόπικο, Βαντόλα Άννα, Βουζίνα Ολυμπία, Βουζίνας Φίβος, Θανάσης Κρικής και Στέλιος Ιντσίδης. Ένα χειροκρότημα σε όλους, ανεβείτε όλοι, ελάτε, εδώ. Thank you very much. Ηλέκτρα. Δώσ' μου το κύπελο του Angel Juror. Σας ευχαριστώ πάρα πολύ. Ελάτε κι άλλοι, ελάτε. Έχουμε χώρο εδώ μπροστά, ελάτε. Κύριε Βαγγέλη, εδώ εσείς σε μένα. Εδώ όλοι μπροστά. Φώναξε την άλλη. Λοιπόν, ένα μεγάλο χειροκρότημα για όλους αυτούς τους ανθρώπους. Τους ευχαριστούμε πάρα πολύ. Εάν ξέχασα κάποιον να έρθει στη σκηνή. Αλλά παρακαλώ μοιράζετε τα μετάλλια όσο μιλάω. Αλλά μοιράζετε τα μετάλλια. Ναι, όλοι. Και αυτοί όλοι θα πάρουν. Αλλά όπως καταλαβαίνετε δεν είναι όλοι οι κριτές το ίδιο. Γιατί σε αυτό το διαγωνισμό παίζει ρόλο και η προσωπικότητα του κριτή. Το καλό που έχει αυτός ο διαγωνισμός και ίσως το κακό που παρεξηγούν πολλές φορές οι ομάδες είναι ότι εξ ορισμού η βαθμολογία εδώ είναι υποκειμενική. Που σημαίνει ότι δεν είναι ένα διαγώνισμα που έχει μία σωστή λύση και άρα ο μαθητής θα καταλάβει που έκανε το λάθος. Εδώ τα κριτήρια του κάθε κριτή είναι διαφορετικά. Όμως, ένας κριτής φέτος το έπαιξε λίγο διαφορετικά. Είπε να γίνει ο αγαπημένος όλων. Είπε να χαρίζει απλόχερα βαθμούς, γιατί έμαθε ότι δεν τους πληρώνει μετά τους βαθμούς που βάζει. Οπότε, φέτος για πρώτη φορά δίνουμε το κριτή του Angel Juror. Το αγγελάκι μας, ο κριτής μας που τον αγαπάνε όλοι. Δεν φαίνεται, αλλά ο καλύτερος κριτής, ο αγαπημένος όλων, που δεν έχει στενοχωρήσει ποτέ άνθρωπο στη ζωή του, είναι ο κύριος Βαγγέλης Κοροπούλης από το Ροδίο Ελπαιδεία. Συγχαρητήρια. Πείτε μας λίγο πώς νιώθετε να σας αγαπάνε όλοι.
Ευχαριστώ πολύ. Δεν το περίμενα. Απλά εγώ πιστεύω ότι και μόνο που τα παιδιά τολμούν και είναι εδώ πάνω, δεν χρειάζεται καν να μπει αρνητική βαθμολογία. Μόνο αυτό.
Thank you everyone. Thank you for coming. Please be seated. Thank you. Thank you very much.
Thank you. Be seated.
Έλα, κάτσε εδώ μαζί μου. Okay. Συνεχίζουμε. Σας ευχαριστούμε όλους θερμά. Ο διαγωνισμός αυτός, όπως ξέρετε, βρίσκεται στην Ελλάδα τουλάχιστον ήδη στην 7η χρονιά του. Αυτό σημαίνει ότι... Έλα από εδώ. Αυτό σημαίνει ότι πλέον έχουμε μαθητές που περάσαν από αυτό το στάδιο, μεγάλωσαν, κάνανε κάτι άλλο στη ζωή τους, προχώρησαν. Οπότε έχουμε ένα δείγμα αυτοί οι μαθητές που μπορούν να φτάσουν και τι μπορούν να κάνουν. Έχουμε λοιπόν εδώ δύο παλιές μας μαθήτριες, νικήτριες προηγούμενου διαγωνισμού, την κυρία Άννη Ζούντζα και την κυρία Ελένη Τσαβδάρογλου. Θέλω να μας πείτε λίγο δύο λόγια πώς το είχατε βιώσει εσείς, τι κάνετε τώρα που βρίσκεστε.
Hi everyone, my name is Annie and I was the captain of the winning team in 2023, I think it was back then. I had been in HYNT and IYNT for 3 years then, and I have to say it was a very nice experience to kind of get acquainted with the sciences, practice public speaking and make some very nice friends along the way. And I think it was kind of the start for me in my scientific journey. Now I will go on to study electrical engineering in university, so needless to say it was something that I decided to keep going with. So I'm very happy to see many kids here interested and eager to continue down the scientific path. And I think I cannot stress enough that it's really not about winning, it's about what you learn along the way and the friends that you make, who you may come here and see after 3 years, just like we did now. But it's really a very nice community, and I would urge each and every one of you to treasure it very much.
Hello, I'm Eleni. I was with Annie as well, one of the winning team in 2023 HYNT. Along with Annie, I started this competition, participating when I was just 13 years old. So I grew up in this competition, and I grew up to learn how to love science and how to research and become a better opponent, reviewer, reporter, whatever that may be. I just wanted to stress that no matter how anxious you may be, no matter how young you may be, especially the ones that have just started this competition, it is never late to improve and grow, and it can really go far, especially in your academic career and your professional career later on in your life. You will realize that the skills you get from participating in this competition do carry on in your life. Thank you.
Thank you very much, and I hope all the best in your life. So, we continue. Okay, we had three tournaments this year. The third Young Physicists League, the guys already have left because, they are in Thessaloniki, they have to see the city, so it wasn't nice of me to keep them here. But, έχουμε εδώ την ελληνική ομάδα. Ποιος είναι από την ελληνική ομάδα? Ελάτε. One of our Greek teams, they succeed to gain the bronze medal. Sounds Greek to me. Come. Κύριε Μανδαλίδη, θα έρθετε να δώσετε το μετάλλιο και να πείτε δύο λόγια. Μάρια, είσαι ο μόνος από την ομάδα. Λοιπόν, να σας ευχαριστήσουμε άλλη μία φορά που μας βοηθήσατε να διοργανώσουμε αυτό το διαγωνισμό. Θα πείτε ένα χαιρετισμό.
Ευχαριστώ πάρα πολύ. Συγχαρητήρια σε όλες τις ομάδες, ανεξάρτητα την θέση που πήραν. Congratulations to everyone who participated in these days here in our schools.
Congratulations, your team will get the medals after. Okay, thank you very much. Okay. Now, the second... Ο δεύτερος διαγωνισμός που είχαμε ήταν ο CupExS, ο CupExS Experimental Science, ένας πολύ όμορφος διαγωνισμός. Mr. Robico, come here to the stage. Είχαμε 4 ομάδες να διαγωνίζονται. Για να μην καθυστερούμε πολύ, ξεκινάμε με την απονομή από τον τέταρτο. Από τον τέταρτο. Come, Robico.
So CupExS Experimental Sciences was another competition that was held these days, which is an experimental competition. Mr. Robico is the person that is in charge of the competition, so he will talk to us right now. We had 4 teams competing, and now we will be giving the rankings out.
Hello, everyone. This was the first year when CupExS went outside the borders of Georgia. Before we only made CupExS inside our country. Now we try to grow bigger, and with the help of Apostolos, we were able to make the tournament happen here in Saloniki. The tournament went even better than I expected. I think that was because of those wonderful participants. Because if they were not so good, the tournament could not succeed. Thank you guys very much. And I'm looking forward in the future so we can have a greater and more interesting experimental tournaments in the future. And this is the perfect start, I would say. Thank you.
Very much. Without delay. Χάλκινο μετάλλιο, η ομάδα Ροδίων Experimenters. Συγχαρητήρια. Ελάτε στη σκηνή. Πού είναι? Robico, we also have a second phase of the tournament in Georgia this year, right? Yeah. Congratulations, guys. Τρίτη θέση, χάλκινο μετάλλιο, η ομάδα Champions. Thank you, guys. Thank you. Thank you very much, Robiko. Now, θα ήθελα να καλέσω να μας βοηθήσει με την απονομή μια κυρία η οποία έτρεξε πολύ αυτές τις μέρες και μας βοήθησε πάρα πολύ, την κυρία Εύη Μάνου. Και να έρθουν για τα ασημένια μετάλλια οι Six Elements. Σας ευχαριστούμε πάρα πολύ για τη βοήθεια, την υποστήριξη, τη φιλοξενία.
Και εγώ να συγχαρώ όλα τα παιδιά που πήραν μέρος και περισσότερο και τους νικητές. Και πιστεύω ότι το μεγαλύτερο κέρδος τους, το μεγαλύτερο βραβείο είναι η εμπειρία και όλη αυτή η απόλαυση του παιχνιδιού.
Ευχαριστούμε. Congratulations, guys. Ευχαριστούμε πάρα πολύ, παιδιά. Συγχαρητήρια. Και επίσης για τη φιλοξενία, να ευχαριστήσουμε την κυρία Μαργαρίτη και αν μπορεί να έρθει να δώσει τα μετάλλια για να μας πει δύο λόγια. Σας ευχαριστούμε πάρα πολύ. Πρώτη θέση και χρυσό μετάλλιο. Sherlock Holmes.
Εγώ θέλω να δώσω συγχαρητήρια σε όλους τους συμμετέχοντες από οποιαδήποτε πλευρά, είτε ήταν διαγωνιζόμενοι, είτε ήταν κριτές, επιτροπή. Εγώ βλέπω, είναι η τρίτη μέρα, ήρθα και την πρώτη μέρα, βλέπω ότι είστε εδώ όλοι παρόντες με το ενδιαφέρον αμείωτο. Δηλαδή μια κοινότητα που δεν χάνει, παρόλο που δεν πήρατε όλη πρώτη θέση, δεν χάσατε το ενδιαφέρον σας και αυτό είναι πάρα πολύ σημαντικό. Πάρα πολύ σημαντικό να είστε εδώ όλοι και να αναμένετε. Συγχαρητήρια και πάλι σε όλους σας.
Ευχαριστούμε. Η Ηλέκτρα θα σας δίνει τα μετάλλια ένα-ένα. Ναι. Ευχαριστούμε πάρα πολύ. Congratulations, guys. Yanni, in English, it's the second time you win this tournament.
I'm thinking about going for the three-peat in the summer.
So 3 times in a row?
Why not?
Just winners. Okay. Ευχαριστούμε πολύ. Να είστε καλά. Και πάμε τώρα στο κύριο γεγονός, στο διαγωνισμό που ίσως έχει και λίγο τη μεγαλύτερη απήχηση, τον 7ο YNL, 7th YNL 2026 Award Ceremony. We will begin from the last to the first place. There are no last places, you are all winners. Mr. Matev, you always say, in this tournament you win as soon as you read the problems. So thank you everyone. And we start. Electra, hit the button. Μία φορά πρώτα. The final ranking. 29th place, Pink Theory. Κύριε Βουρλιά.
Και οι τελευταίοι έσονται πρώτοι. Του χρόνου θα είστε πρώτοι. Συγχαρητήρια. Συγχαρητήρια, παιδιά. Είναι με τα ονόματα τώρα. Έβαλε μονή. Εσύ, πάρε. Νικολέτα, Καγάκη, εσύ. Ιουλία, Καγάκη. Θα τα μοιράσω. Έλλη Νικηφορίδου, Σοφία Μαρία και το κρατάτε εσείς. Δώσε μου και το μετάλλιο.
Μίλησες. Congratulations, girls. Okay, it was their first time, right? Who's going to speak?
Πάμε καλύτερα του πρώτου.
Next year?
We hope next year we'll do better. And congratulations to everyone.
Thank you very much.
Μπράβο.
Mr. Matev, please come to the stage. I mean, these days you are helping us so much, but you have one more obligation. 28th place. Πάτα. Vishok. Mr. Matev,
While they're coming up, it's a great pleasure for me and a great honor to be here again. I hope that you share the excitement of all of the teams that are coming here. Some of them, hopefully many of them, will start their scientific career from this very exciting experience. Looking forward to seeing them on the different stages in the future. I hope somebody, or at least most of us, have picked up some of the sparks from this tournament and look forward to seeing many of you in the future.
Thank you. Congratulations.
Congratulations.
Okay, thank you guys. Mr. Matev, stay here. 27th place, Team Quanta. Come to the stage, guys.
Quiet in the room, please.
Congratulations, guys. Thank you for coming here. Thank you very much. '26th place, Summit Collective and Quantum Rush. Nicoletta.
Unfortunately, our captain isn't here, and the fellow team member is also absent, so I'd like to thank everyone and congratulate all of you, and remind you that your ranking does not define who you are. Thank you.
I guess I need one.
Congratulations. Στα αυτά εκεί που σε είπε το. Well done, guys. Thank you. 25th place, Hot Reactions. Well done, girls and boys.
Thank you, everybody. We had some great fights. We learned a lot from our opponents, and we're going to be back next year.
We're waiting for you. Thank you very much. 24th place, AFS Researchers. Well done, guys. Συγχαρητήρια, παιδιά. Έλα, ποιος θα μιλήσει.
Θέλω να μιλάω. Okay. This was our first year in the competition. We came here to have fun. See you next year.
Thank you very much. Congrats. Okay, thank you, guys. 23rd place, Rhodion Experimenters. Congratulations, guys. Thank you very much, guys. 22nd place, Nova Pioneers.
Thank you for this opportunity. It was very fun, and we hope to see you again soon.
Thank you. Congratulations. Thank you, guys. Hopefully see you next year. 21st place, Natura Revolt from Cyprus. You are going to talk. Say something. You, I like it.
Okay. Thank you to everyone who went against us. We learned a lot, and as a first year, it was a lot of fun. We're hoping to come back stronger next year, and yeah, thank you.
Congratulations. Thank you very much. Now, let's proceed to honorable mentions. 20th place, creative physicists.
Thank you all for being here, and I think we all did a great job. That's it.
Congrats. Congratulations, guys. Thank you very much. 90th place, honorable mention, Lyceum, India.
It was a great experience, and we are hoping to do better next year.
Τα παιδιά είναι από διαφορετικά σχολεία και αυτό είναι το σημαντικό με αυτό το διαγωνισμό. Μπορεί να είναι πρώτη φορά, νομίζω, όλοι μαζί συγκεντρωθήκατε σήμερα, προχθές δηλαδή. Και αυτό είναι το ωραίο με τον διαγωνισμό αυτόν. Τα παιδιά προπονούνται διαδικτυακά από την Ένωση Ελλήνων Φυσικών και καταφέρουν να πάνε αρκετά καλά, παρόλο που δεν βρίσκονται όλοι στο ίδιο σχολείο, στο ίδιο χώρο. Ευχαριστούμε, παιδιά. 90th place, honorable mention, chemically bonded.
So, hello everybody. I just wanted to say that we are very thankful on being on stage right now, and don't be upset on what place you got. Just know that next year you can come back stronger and better. Good luck everybody, and thank you.
Και αφού μου την είπαν οι Αγγλικούδες, θα αλλάξω λίγο την προφορά μου. Congratulations, guys. Thank you very much. 18th place, honorable mention, Vanda. Έλα, τσικ.
Thank you very much for this amazing tournament. And
and great job to everyone. Bye.
Congratulations, guys. Thank you very much. 16th place, honorable mention, mass times acceleration. Afro, say something.
Ευαγγελία, ευχαριστώ πολύ. Γιατί είναι το δικό σου
We had a great experience throughout this tournament, and we liked it very much, and we hope to get next year back stronger and better. Thank you very much.
Thank you. 15th place, honorable mention, Team Gaia. Congratulations.
Complicated way, sorry. Could you do that?
No, but I want to say something.
Well, looking forward to seeing you again in the future.
Yes, it was an amazing experience, and we can't wait to come back again.
Alex. 14th place, honorable mention, Team Axiom. Will you say a few words?
Have to share it with everyone.
I'm glad that you're here and looking forward to seeing you in the future. So, make a very good and happy career in the future.
We are very grateful to be here, and thank you for the invite. It was a very engaging number of debates. Thank you very much.
13th place, honorable mention, Event Horizon. Event Horizon, come to the stage. Mr. Matev, are you proud of this team?
Looking forward to seeing you again.
So we're Event Horizon. For most of us, it was the first time joining, but we only have great memories from this competition. And considering the fact that it was our first time meeting each other, we were complete strangers. We bonded immediately and just had a lot of fun. So thank you.
I missed one here.
Thank you very much. Congratulations. Thank you very much, guys. 12th place, honorable mention, Magneticians.
We are so honored to be here. Congratulations to everyone.
Thank you for being here.
Thank you. I like your name. I like the team name. Eleventh place, honorable mention, Team Orion.
Thank you everyone for this wonderful journey. I would like to thank my team and Mr. Michaloudis for bringing us here.
Thank you very much. Congratulations, girls. 10th place, honorable mention, Team Vexora.
We are Team Vexora. We are really grateful for our position, even if we were so close to the semi-finals. We would like to thank all the jurors for this wonderful journey and see you next year.
Congrats. Congratulations, guys. Φτάσαμε ακριβώς πριν τα μετάλλια. Οι πρώτες 9 ομάδες είναι αυτές που κατάφεραν χθες το βράδυ να είναι στους ημιτελικούς.
We are to the point where we're going to start giving medals. The teams you'll see right now are the teams that were able to go to the semifinals yesterday.
Αλλά πριν από αυτό,
but before that,
Έχουμε να δώσουμε τα κύπελα, τα ατομικά κύπελα του καλύτερου reporter, opponent και reviewer.
We have to give the individual awards for the reporter, opponent and reviewer for the preliminary rounds.
Έχουμε τη χαρά να έχουμε μαζί μας τον κύριο Γιαννακό, αντιδήμαρχο παιδείας του Δήμου Καλαμαριάς. Να τον ευχαριστήσουμε για άλλη μια φορά που βρίσκεται εδώ μαζί μας και για την υποστήριξη του Δήμου για όλη αυτή τη διοργάνωση. Κύριε Γιαννακέ.
Θερμά συγχαρητήρια σε όλους τους συμμετέχοντες. Θερμά συγχαρητήρια στην Ένωση Φυσικών, στην Ένωση Ελλήνων Φυσικών για αυτή την καταπληκτική διοργάνωση. Θερμά συγχαρητήρια στους νικητές, αλλά και σε όλους τους διαγωνιζόμενους, σε όλους τους συμμετέχοντες. Τέτοιες εκδηλώσεις είναι μεγάλη τιμή να γίνονται στο Δήμο μας και ελπίζω να αντίστοιχες εκδηλώσεις και αντίστοιχες εμβέλειες εκδηλώσεις να γίνουν και στο μέλλον. Ευχαριστώ πολύ.
Mr. Giannakos said that he's very thankful that the competition happened in Kalamaria, and he's very happy for the collaboration with the Hellenic Physical Society. So we can start with the individual awards.
So, best reporter for the first 3 selective fights was Konstantinos Miroforidis from Creative Physicists. Where is he? Okay, he will be here. Κωνσταντίνος έφυγε. Best opponent for the first 3 selective fights. Νακάτο Μαρία Μουγκάκα, Team Ether. Άμα βρείτε το Μυροφορίδη έξω να τον φωνάξετε να έρθει. Congratulations. Well done. Okay. So, the cup for the best reporter to Konstantinos Miroforidis. Congratulations. And best reviewer for the first 3 selective fights, Doris Nivahereza, Team Calix. Θες να την πεις αυτή τη συγχαρητήρια? Μην το ανοίξεις. Ναι, απλά μην το ανοίξεις. Πόσο δεν είναι κυρία Νάτα. Πόσο δεν είναι κυρία Νάτα. Κοίτα. Congratulations. Well done. And one final is the MVP, the most valuable player for the selective science fights is Hilal Izam Nezadin, MC Crew. Χιλάλ, πώς νιώθεις που κουβάλισες στην ομάδα σου?
I'm really shocked. Thank you very much for the award. And also, I'm very thankful for my team because they were the ones that collaborated and helped me throughout the process. Thank you very much.
Να ευχαριστήσουμε για άλλη μια φορά τον κύριο Γιαννακό. Σας ευχαριστούμε θερμά. Οι ομάδες οι οποίες δεν προκρίθηκαν χθες στους ημιτελικούς είχαν την ευκαιρία να διεκδικήσουν κάποια κύπελα στο λεγόμενο experimental race.
The teams that were not on the semifinals yesterday, they were able to participate in the experimental race.
Είναι κάτι λίγο διαφορετικό, κάτι μοναδικό, καθώς οι ομάδες έπρεπε εκείνη την ώρα να πραγματοποιήσουν κάποιο πείραμα και να το εκτελέσουν καλύτερα από άλλους.
It's something different and unique because the teams should do experiments and do it better than the rest of the teams competing on the race.
Επομένως, το πρώτο κύπελο από το experimental race κερδίζει η ομάδα Orion. Συγχαρητήρια. Σας άρεσε η διαδικασία?
This is great.
I have to say, we loved that experiment. Yeah. Great job, everybody.
Congratulations. The next cup for the second experimental race goes to Team Vexora. Congratulations, guys.
So thank you all for this cup. It means a lot to us for us to be able at this stage. Congratulations to all of the other teams that competed in it, and we're grateful to also be here next year. Thank you.
Congratulations. And MVP team for this challenge was Team Nova Pioneers. Well done, guys.
Really well, but congratulations. Who is the captain?
The last one. Thank you very much. We enjoyed doing these experiments very much.
Και συνεχίζουμε. Βλέπετε, έχουμε να βραβεύσουμε πολύ κόσμο εδώ. Ο διαγωνισμός δίνει πολλά βραβεία. Γιατί?
And we will continue because the tournament gives many awards.
Γιατί αναγνωρίζει την προσπάθεια των μαθητών να βρεθούν εδώ. Οι μαθητές δεν ξύπνησαν προχθές και είπανε πάμε να παίξουμε σε ένα διαγωνισμό.
Because we understand and respect the efforts the students give for this competition. The students don't just wake up and don't have anything to do.
Για να καταφέρουν να είναι αυτό το διήμερο μαζί μας, έπρεπε να προετοιμαστούν όλη τη χρονιά, να λύσουν τα προβλήματα, να ετοιμάσουν τα PowerPoints, να προετοιμαστούν για τους ρόλους και να έρθουν να διαγωνιστούν. Και γι' αυτό τους αξίζει ένα μεγάλο μπράβο.
For them to be able to be here, they were preparing the entire year. So for that, they deserve a huge congratulations.
Αλλά πάντα κάποιοι είτε λόγω τύχης, είτε λόγω ικανότητας θα πηγαίνουν λίγο καλύτερα από τους υπόλοιπους.
But some teams and participants, for either reasons of luck or skills, do better than others.
Οπότε, let's proceed to the medals of this year's YNL.
Great.
So, the teams that made it, better you translate. Οι ομάδες που κατάφεραν να είναι χθες στους ημιτελικούς κερδίζουν όλοι χάλκινο μετάλλιο.
So the teams that were able to have a spot yesterday on the semifinals, they all win a bronze medal.
Ενώ οι ομάδες που κατάφεραν να βρίσκονται σήμερα μαζί μας στο τελικό κερδίζουν το ασημένιο και το χρυσό μετάλλιο.
While the teams that were here today with us on the finals will win the silver and gold medal.
Επομένως, ένατη θέση και χάλκινο μετάλλιο κερδίζει η ομάδα The Incredibles. Συγχαρητήρια.
Hello, we're so grateful and happy to be among the top teams. It was a wonderful experience. Thank you.
Έλα, Ηλέκτρα. Να. 8th place. 8η θέση. Bronze medal, χάλκινο μετάλλιο, κερδίζει η ομάδα. The Outliers.
Congratulations, Captain. Go ahead and say something.
Thank you very much for this opportunity. We want to thank all of the team leaders and Mr. Apostolos for this amazing organization, and we tried our best. Thank you.
Κύριε Σωτήρη, κύριε Σωτήρη, κύριε Σωτήρη. 7th place, 7η θέση, χάλκινο μετάλλιο, bronze medal, goes to Team Calix. Come guys. Hey, Mr. Matev, don't go. You haven't finished yet. Congratulations.
Thank you so much for this opportunity. We were honored and it was a great fate. Thank you.
Thank you for being here. You did very well. Looking forward to seeing you again in the future competition of this kind. Better success and more learning.
Well done. Thank you. 6th place, bronze medal. 6η θέση και χάλκινο μετάλλιο, κερδίζει η ομάδα. Fusion Force. Congratulations, guys.
I want to say thank you for this amazing experience. We are very grateful for this award. And thank you, everyone.
Congratulations. Thank you guys, congratulations. 5th place and bronze medal. 5η θέση, χάλκινο μετάλλιο, η ομάδα. MC Crew. Συγχαρητήρια.
First of all,
all, thank you to everyone and mostly to Mr. Apostolos for these 3 amazing days. Thank you to the team leaders and thank you to my team.
Well done. Thank you. And 4th place and bronze medal goes to Team Ether. Congratulations. Well done.
Hello, everyone. We're very honored to be here. It was a wonderful experience. Thank you very much.
A big applause. Dodo, βοήθα. Mr. Matev, go rest. Λοιπόν, Dodo, φτάσαμε στα μετάλλια του τελικού αγώνα.
Φτάσαμε.
Πριν όμως,
ναι,
κάποιος μπόρεσε και κατάφερε και έφτασε την ομάδα του λίγο πιο ψηλά.
Ναι.
Κύριε Βρουλιά, θα έρθετε να μας βοηθήσετε. MVP of the semi-finals. Κατερίνα Μανιτάκη από την ομάδα Revolutionaries. Congratulations.
Thank you so much. This is such an honor. This is my 3rd time being in the finals, but I want to say thank you to my team because we worked so hard together. And congratulations, everyone. I'm so happy.
Now this is the big moment that you all have been waiting for, but you are going to wait a little more. I would like to invite to the stage the 3 captains, please. Λοιπόν, εγώ θα μιλάω ελληνικά και εσείς αγγλικά για να καταλαβαίνουν όλοι. Εμπειρία, πάμε. Πώς ήταν ο τελικός?
Ελληνικά, είπαμε. Οκ, εγώ θα το πω στα ελληνικά. Εμένα ήταν η 3η μου χρονιά που ήμουν στο τελικό. Και εγώ πρέπει να πω ότι πέρασα τέλεια, γιατί πραγματικά ευχαριστήκαμε την ομάδα μας και αυτός ήταν ο στόχος μας ο βασικός. Τώρα το τελικό αποτέλεσμα είναι πραγματικά δευτερεύον, γιατί πραγματικά απολαύσαμε το διαγωνισμό. Αυτό.
Ioana said she's very happy to be here for the 3rd time, correct? Yes. For the tournament with her team, and she said that she doesn't care about the result because the journey is what matters, correct?
Well, maybe she does a little.
She does a little, but yeah.
Ελληνικά.
Λοιπόν, ήταν μια πάρα πολύ ωραία εμπειρία. Χάρηκα πολύ που είχαμε την ευκαιρία να είμαστε σε αυτό το fight. Και ειλικρινά και εγώ θεωρώ ότι περάσαμε όλοι πάρα πολύ καλά. Και τώρα όποιος έχει πάρει το χρυσό και όποιος έχει πάρει το ασημένιο δεν μετράει καθόλου, όπως είπε και η Ιωάννα. Γιατί όλοι περάσαμε καλά και κάναμε το καλύτερο που μπορούσαμε. Όλοι δείξαμε τους καλύτερους μας εαυτούς από όλες τις ομάδες. Ήταν μια πολύ ωραία εμπειρία.
Michaela said that she's glad again to be in the finals as well, and that again the journey is what matters, and that she doesn't care about the result, as everyone gave their best today, and they're all.
Ναι, και εμείς και η ομάδα μου, νομίζω, αρχικά ήταν η πρώτη μας φορά που συμμετέχουμε σε τελικό, οπότε ήταν κάτι διαφορετικό για μας. Αλλά ναι, γενικά μας φάνηκε και εμάς μια πολύ ενδιαφέρουσα εμπειρία. Δώσαμε και εμείς ό,τι καλύτερο μπορούσαμε, αλλά ναι, όπως είπαν και τα κορίτσια, δεν μετράει το ποιος θα βγει νικητής τελικά.
So they agreed as well that the experience is what matters, and they gave their best. So good luck, everyone.
Okay, stay here. Stay here. So, third place and silver medal goes to a team that performed very well.
Very well.
But the others just a little bit better. Team, who do you think was the third one?
I know, I can say.
You know?
I know, I can say.
Are you sure?
Yes.
Third place and silver medal goes to team Revolutionaries. Congratulations, come.
Δεν έχουμε Κλεοπάτρα. Χριστίνα Νιάνου. Χριστίνα. Εγώ είπα. Εγώ μίλησα.
This is my first time in the tournament, but I really enjoyed the experience, and I'm really glad I was a part of it.
Εμένα ήταν η πρώτη μου φορά στο διαγωνισμό. Ήταν μια πάρα πολύ ωραία εμπειρία. Είχα την καλύτερη ομάδα και την καλύτερη κάπτεν και το απολαύσαμε πραγματικά. Οπότε, ναι.
Και εμένα ήταν η πρώτη μου φορά στο διαγωνισμό και ναι, το απολαύσαμε full. Ήταν πολύ ωραία και χαίρομαι πάρα πολύ που φτάσαμε μέχρι εδώ. Αυτά.
Congratulations, girls. I'm going to say something that... Ντοντό, θα μεταφράσεις. Θέλω να πω κάτι, ότι αυτή η ομάδα, τουλάχιστον κάποια από αυτά τα κορίτσια,
at least some of these girls,
ήταν το καλοκαίρι στο Καζακστάν.
Were this summer in Kazakhstan in internationals.
Ήτανε μόνο 4 άτομα.
Only for
που
people
σημαίνει
on team,
ότι θα έτρωγαν πολλές ποινές.
which means that they would get many penalties during the rounds.
Και όμως κατάφερε με τη στρατηγική τους να τρώνε ποινές ελεγχόμενα.
But with their strategy, they were able to get penalties controllably.
Και να καταφέρουν να είναι στον τελικό.
And to be able to go to the finals even with the penalties.
Ακόμα και ο πρόεδρος του διαγωνισμού με έπιασε την τρίτη μέρα.
Even the president of the tournament
the international tournament
went to in the international tournament went to Apostolos and told him on the third day.
The third day, and he told me, now I understand what they are doing.
Now I get what they're.
Ούτε αυτός δεν κατάλαβε, ούτε αυτός δεν κατάλαβε τη στρατηγική.
He didn't even understand.
Congratulations.
Even he couldn't understand the strategy.
Okay, well done. Κύριε Βρουλιά, πώς το βλέπετε?
Εγώ δεν βλέπω την Ηλέκτρα όμως. Πού είναι η Ηλέκτρα?
Είναι πίσω αυτή τη στιγμή.
Ηλέκτρα, έλα εδώ Ηλέκτρα. Η Ηλέκτρα γεννήθηκε μαζί με το διαγωνισμό. Ελπίζω ο διαγωνισμός να έχει την πρόοδο, την ομορφιά και την εξέλιξη αυτού του κοριτσιού και να τα εκατοστήσει η Ηλέκτρα και ο διαγωνισμός μας.
Ευχαριστώ.
Συγχαρητήρια σε όλους τους συμμετέχοντες από μένα, μα πάνω απ' όλα συγχαρητήρια στον Ποστρότο Μιχαλούδη, ο οποίος χάνει την Ένωση Ελλήνων Φυσικών σήμερα να είναι τόσο υπερήφανη. Σε ευχαριστούμε. Δώσε το λόγο στον Άντρη Χριστιανό.
Πήγαινε δώσε λίγο το μικρόφωνο στην Άντρη και στον Άντρη.
Ναι.
Αλλά πριν αποφασίσουμε ποιος κέρδισε τελικά το διαγωνισμό, κάθεστε αναπαυτικά. Κάθεστε. Ας μας πούν οι κριτές πώς είδανε. Let's ask the jurors how they see the fight. Έχετε πτήση να πάρετε. Θα περιμένω, ο πιλότος είναι φίλος μου. Κώστα. Σε μία από αυτές.
So the question was, how was the final fight?
How did you guess?
Right. Well, again, the enthusiasm of everybody, it's really as if they are trying to pass entrance exam to Harvard. They're all really, really passionate about what they are doing. So I think it's an inspiration for anybody who is then watching what they are, who is participating as observer, because each of them is really trying to defend their thing. So well done, people. And as they say, it's what you learned by being here. I like that point. And the friends you make. Thank you. Ευχαριστώ παρακαλώ.
Something very important, and I want you to remember. Something very important that I want you to remember from this kind of tournaments is that here you win the prize for the best of what you have done with your own hands, and that would give you the pride and the authority to claim that what you are saying is something that has come as a result of your own understanding and labor, and you can actually claim to know more than your teachers on a particular subject in which you have done your own experiments. That's one of the unique things about this kind of competitions. In other competitions, you may be afraid that you'll be getting, questions, difficult questions, etc. But in this case, you have the authority to stand on your own position that you have actually, defended by doing your own experiments and defending it on the stage. So yes, in some cases, you can know more than your teachers, and be proud of it. No,
No one. Okay. So, without any delay. I would like to invite the two finalists to the stage.
The entire team.
Maybe one team here and the other team there.
Αυτό παίρνετε, αυτό παίρνουνε.
Who performed in the final fight? Καλέντης.
Πραγματικά ήταν κάτι μοναδικό, στο τελικό ιδιαίτερα και σε όλα τα fights. Κάθε εμπειρία, κάθε επιχείρημα που λέει κάποιος, κάθε πρόβλημα είναι κάτι ξεχωριστό το οποίο σκέφτεται πραγματικά πριν το πει και καθορίζει κάθε στιγμή και το πόσο όμορφα μπορεί να περάσει κάποιος. Και αυτή η αδρεναλίνη, η ένταση που έχει κάποιος και χαίρεται καθ' όλη τη διάρκεια που παρουσιάζει, παίζει οποιοδήποτε ρόλο, πραγματικά είναι αυτό που κάνει ξεχωριστό αυτό το διαγωνισμό.
Εμένα μου άρεσε πάρα πολύ. Ήταν η πρώτη μου φορά που συμμετείχα στο τελικό. Και πραγματικά συγχαρητήρια και σε όλα τα παιδιά που συμμετείχαν στο διαγωνισμό.
Πάμε από εδώ. Ποιοι παίξανε? Ηλιάνα, σε είδα. Μην κρύβεσαι.
Εγώ έχω να πω, όταν μου προτείνανε τα παιδιά να έρθω στην ομάδα τους, ο Αναστάσης μου είπε εμείς έχουμε στόχο για φέτος να πάμε στους τελικούς και το είπανε και το κάνανε και ήταν η καλύτερη ομάδα που θα μπορούσα να ζητήσω. Σας ευχαριστώ πάρα πολύ, παιδιά.
Καταρχάς, συγχαρητήρια και στις δύο ομάδες τελικούς και σε όλες τις ομάδες του διαγωνισμού. Ήταν πραγματικά μια ξεχωριστή εμπειρία. Ο τελικός, ειδικά κάτι που εμείς δεν έχουμε ξαναβιώσει ποτέ. Ελπίζω να το ξαναβιώσουμε. Και τα παιδιά ήταν μια πολύ καλή ομάδα, τις οποίες παίξαμε και τους ζητώ συγχαρητήρια.
Ντοντό. Ωραία. Λοιπόν, ξέρετε, τα προηγούμενα χρόνια, Ηλέκτρα, ξέρετε, τα προηγούμενα χρόνια ανακοινώναμε τον νικητή, τον δεύτερο μάλλον νικητή, οπότε ο πρώτος ενθουσιαζότανε, αλλά ο κύριος Κουκλιάτης εκεί πέρα που τον υπερευχαριστούμε που είναι κάθε φορά μαζί μας και χρησιμοποιεί την καλή κάμερα που με δείχνει λίγο πιο όμορφο.
You know that this past years we've been announcing the second place, so the team that got the first place was getting excited, and
αλλά η κάμερα δεν το έπιανε.
But the camera wouldn't catch it.
Οπότε ο κύριος Κουκλιάτης μου έδωσε την εξαιρετική ιδέα να έχουμε και τις δύο ομάδες πάνω.
So Mr. Kuklaris gave the amazing idea of having both of the teams on stage while announcing the results.
Ωραία. Άρα, δεύτερη θέση.
Second place.
Και ασημένιο μετάλλιο.
And silver medal.
Κερδίζει η ομάδα.
Wins.
Team. Oh, sorry. Batteries. I need batteries. Anyone has batteries? Triple AA. Triple AA.
Νομίζω έχει εκεί ένας κύριος.
Δεύτερη θέση και ασημένιο μετάλλιο. Κερδίζει η ομάδα.
Goes to
Absolute Zero.
Να φωνάξει το φίβο να τους θα δώσει το μετάλλιο. Εσύ. Εγώ σου πήγα το μήνυμα.
Μπράβο παιδιά, πραγματικά είναι πολύ συγκινητικό που είστε εδώ για δεύτερη χρονιά. Πέρσι τι θέση είχαμε πάρει? 16η. 16η και τώρα δεύτερη. Και ένα μετάλλιο στο Καζακστάν. Το λες και πρόοδο. Συγχαρητήρια. Θέλει να πει κάποιος κάτι? Κάπτεν. Ευχαριστούμε. Ναι.
Ευχαριστούμε για την εμπειρία και θα σας δούμε ξανά του χρόνου.
Μπράβο παιδιά, μπράβο. Μπράβο, συγχαρητήρια. Και όπως καταλάβατε, πρώτη θέση και χρυσό μετάλλιο, ο τίτλος του απόλυτου νικητή πηγαίνει στην ομάδα Lab Legends.
Λοιπόν, εγώ έχω κατέβει σε 3 διαγωνισμούς, ένα παγκόσμιο και 2 διεθνείς, πανελλήνιους, που τώρα διεθνείς έχει κάνει ο Απόστολος και μπράβο του. Είναι η πρώτη φορά που κατέβαινα στο τελικό και είμαι πολύ περήφανος για την ομάδα μου, για όλη τη δουλειά που έχει πέσει, για τον Φίβο εκεί πίσω που μας βοήθησε, τη Μαρία. Φίβο, έλα εδώ, Φίβο. Έλα εδώ, Φίβο. Γενικά, ναι, ευχαριστώ πάρα πολύ. Συγχαρητήρια σε όλους σας. Είναι και μπράβο σας που έχετε έρθει εδώ πέρα. Και ναι.
Εμένα ήταν η πρώτη φορά στο διαγωνισμό. Ήταν υπέροχα. Το έχω ακούσει από όλους. Ήταν πάρα πολύ ωραία. Όλοι εδώ πέρα είστε πραγματικά υπέροχοι. Και ευχαριστώ πάρα πολύ την κυρία Γκρίτζελη που μου το πρότεινε και το Φίβο που με βοήθησε. Και ευχαριστώ πάρα πολύ για όλα. Ήταν όλα υπέροχα. Αυτά και είχα μια υπέροχη ομάδα.
Εγώ πραγματικά θα πω πάλι συγχαρητήρια σε όλους σας. Η ομάδα μου ήταν φανταστική και συνεργαστήκαμε πάρα πολύ ωραία μέσα σε όλα τα stages και τα science fights. Αυτά από μένα. Δεν έχω λόγια.
Ήταν μια εξαιρετική εμπειρία. Ήταν πραγματικά υπέροχη. Συνεργαστήκαμε όλοι πάρα πολύ καλά. Και δυστυχώς είναι η τελευταία μας χρονιά στον YNL, αλλά θα συνεχίσουμε με τους διαγωνισμούς και είμαι σίγουρη ότι και όλοι εσείς θα τα πάτε υπέροχα και συγχαρητήρια σε όλους.
Πραγματικά κάθε φορά που παίζαμε είναι και πιο ωραία εμπειρία, μοναδική εμπειρία. Ειδικά για πρώτη φορά για μένα στο τελικό. Ευχαριστούμε απίστευτα την κυρία Γκρίτσελη για τις ώρες στο εργαστήριο, το Ιωφίβο για τις ώρες στα meetings πιο μετά, και τον κύριο Μιχαλούδη για τον οργανισμό και την απίστευτη ομάδα που έχουμε αυτή τη στιγμή εδώ.
Όπως είπαν και τα παιδιά, ήταν μια φοβερή εμπειρία, φοβερή ομάδα. Χαιρόμαστε πάρα πολύ που ήμασταν εδώ πέρα με όλες τις ομάδες και από όλες τις χώρες. Και ένα μεγάλο ευχαριστώ και στην κυρία Μαρία και στον Φίβο, τους team leaders μας. Χωρίς εσάς δεν θα πηγαίναμε πουθενά.
Χωρίς εσάς δεν θα πηγαίναμε πουθενά.
Πώς νιώθετε?
Εγώ απλώς θα συμπληρώσω ότι χωρίς εσάς δεν θα πήγαινα πουθενά. Αυτό.
Εδώ ο Φίβος Βουζίνας είναι το μυαλό της παρέας μας και δεν ξέρω πώς τα καταφέρνει οι ομάδες που προπονεί, γιατί λίγο μοιράζονται τα παιδιά τις ομάδες για να μπορούν να έχουν τον έλεγχο. Οι ομάδες που προπονεί πάντα, νομίζω ότι είσαι ο Λουτσέσκου του διαγωνισμού, γιατί θα το πάρουμε εμείς φέτος.
Τίποτα, εγώ θέλω να πω ότι τα παιδιά το κάναν πολύ εύκολο να κάνω το coaching φέτος, οπότε αυτό είναι το τέτοιο. Δεν είναι ότι εγώ έχω το τέτοιο, είναι το πώς αντιδρούν τα παιδιά στη δουλειά που θέλουν να κάνουμε. Και αυτό ήταν υπέροχη φέτος. Μπράβο σας.
Ωραία, ευχαριστούμε. Ηλέκτρα, που πας? Μας έμεινε κάτι ακόμα, το κύπελο του MVP του τελικού αγώνα, και το κύπελο αυτό πηγαίνει φυσικά στο χαρισματικό κορίτσι Μιχαέλα Κρασνίδου. Συγχαρητήρια. Μπράβο, κάπτεν. Λοιπόν, άντε καθίστε. Πολύ ωραία είστε εδώ όρθιοι. Ηλέκτρα. Ο διαγωνισμός... Έλα, κάτσουμε εδώ. Έλα, κάτσουμε εδώ. Έλα, κάτσε. Ο διαγωνισμός μας τελείωσε. Σου άρεσε η τελετυλίξης?
Μου άρεσε η τελετυλίξης.
Όμως όλα τα πράγματα κάποτε τελειώνουν. Φυσικά σας περιμένουμε όλους του χρόνου από Σεπτέμβριο με τα νέα προβλήματα του διαγωνισμού. Αλλά πριν από αυτό έχουμε πάρα πολλούς ενδιαφέροντες διαγωνισμούς μέσα στο καλοκαίρι. Έχουμε να πάμε στο Πανεπιστήμιο της κυρίας Μπέβερλι. Έχουμε να πάμε στο διεθνή διαγωνισμό στην Τυφλίδα της Γεωργίας, με οικοδεσπότη τον κύριο Ρόμπικο και την ομάδα του. Ηλέκτρα, να το τελειώσουμε? Πάμε, τι θα πεις?
Κηρύσω τη λήξη του διαγωνισμού. Καλό Πάσχα!
Καλό Πάσχα!